I think we're going to go ahead and get started here in just a moment. As soon as everyone calms down and finds a seat, we'll get kicked off. So I'm Mindy Mislevic. I'm the Senior Director of Outreach and Chief of Staff for the Data Science Institute. And just a few announcements. So the exits are in the back of the auditorium. We will have, we'd love it if you use the back exit instead of coming up to the stage where our presenters will be. We do have an audience joining us on live stream, so welcome to you as well. We will have a intermission about midway with refreshments, so if you can't make it though, do please use the exits in the back of the room. It is my pleasure to use this opportunity to introduce our Provost. Kai Lee is the Provost of the University of Chicago and the David Lee Schilling Law Distinguished Service Professor in the Department of Chemistry, the James Franck Institute, the Institute of Biophysical Dynamics, and the college. In her current role and her prior position as Vice Provost for Research, Provost Lee was instrumental in bringing the university's vision for data science to fruition. Welcome, Provost Lee.
Thank you, Mindy, for the warm welcome. And thanks to everyone here for joining us today at this very special event as we are celebrating the launch of the University of Chicago Data Science Institute. The opportunity to establish and define a new field of scientific inquiry with relevance across many branches of scholarship does not come along every day. Data science presents one of these rare moments as a field that is based in established discipline, including computer science, statistics, and applied mathematics, but with new potentials for foundational discovery and applications when developed in combination with other areas of research. Now, the planning of this Data Science Institute stretches back several years, thanks to the generous gift from the Neubauer and Liu families in 2016 for the development of major initiatives in computer science and data science. That very same year, we were very fortunate to be able to recruit Michael Franklin, who came to us from the University of California, Berkeley, as the inaugural holder of the Liu Family Chair of Computer Science, and also serve as a senior advisor to my office for computation and data science. Mike quickly partnered with Dan Nicolai, professor and chair of statistics, to craft a bold vision for the University of Chicago data science, keeping with the university's long tradition of pioneering new fields and defining new schools of thought. Data science at the University of Chicago would build upon the traditional strength in developing new and powerful tools and techniques while also strengthening the theoretical foundation for this emergent field. It would consider the societal impact of data science, its incredible potential for positive change, the economic value of this new data ecosystem, and the question it raises around ethics and privacies. These efforts led to the creation of new undergraduate data science minor and major, and the recruitment of senior faculty leadership, such as Nick Fimster, I'm trying to look for Nick in the audience, who is the Neubauer Professor of Computer Science, and Rebecca Willett, who is the Professor of Statistics and Computer Science. We also established the Center for Data and Computing, a campus hub for data science and artificial intelligence research that provided seed funding for over 30 ambitious interdisciplinary projects. In 2020, we recruited David Yuminski to serve as the executive director of the new Data Science Institute, which was built upon the success of the Center for Data and Computing with expanded research, education, as well as outreach programs. Since the launch of the Data Science Institute last fall, we have seen rapid and impressive growth in their activities, many of which you will hear about today. The Data Science Institute will be a remarkable resource for the entire university. enriching research and education across campus, and literally touching every single department, division, and school. Its educational activities includes the undergraduate, the master's, as well as the graduate data science programs, along with outreach to pre-collegiate students that will attract the brightest minds to the university. In the research arena, the Institute would enable innovative, new interdisciplinary collaborations, using data science as a bridge to unlock powerful new combinations of expertise across fields. And it would help the University of Chicago continue to push the frontier of science and inquiry while confronting the world's most significant questions and challenges. To tell you more about the UChicago vision for data science, I would now introduce the Institute's two faculty co-directors. Michael J. Franklin is the Liu Family Chair of Computer Science and Senior Advisor to the Provost on Computation and Data Science. He's an authority on databases, data analytics, data management, and distributed system, and is one of the original creators of Apache Spark, a leading open source platforms for data analytics and machine learning. Dan Nicolai is the chair of the Department of Statistics and professor in statistics, the Departments of Human Genetics and Medicine, and the college. His research interests focus on the areas of statistical genetics and mathematical statistics, including applications to genetics and genomic studies on common and complex diseases, as well as system biology. Mike and Dan, thank you for your incredible work so far, and I would now turn the podium to you. Thank you.
Okay, well, thank you, Provost Lee, for that kind introduction and for doing most of our job for us, I think. Thanks everybody for attending, joining us for this exciting event. So I think by now, pretty much everyone realizes that virtually all aspects of human endeavor are becoming increasingly data-driven. But it's also become apparent that we're at an inflection point where the techniques of machine learning, artificial intelligence, and analytics are having a transformative effect on universities, impacting virtually every field of inquiry. Data science represents a revolution for science and scholarship at large. It's a new way of transforming our most valuable resource, data, into unprecedented discoveries and technologies around the most important challenges in science and society. So what is data science? Well, data science is a study of obtaining value from data. It's a simple definition, but it hides behind it a vast array of questions and challenges: practical, theoretical, social, ethical, and more. In its modern incarnation, data science has its roots in industry, when large internet companies needed to recruit people with a new skill set, a combination of computing prowess, statistical knowledge, and domain expertise that differed from previous job categories. However, at the University of Chicago, we recognize that the implications of data science are far broader and deeper than simply a new job category. And based on this, we've created the Data Science Institute to explore, understand, define, and enhance this new intellectual landscape.
Maybe I'll say a few words first about the history of the Data Science Initiative and Institute. And the starting point for the Data Science Initiative was a campus-wide committee that had representatives from across the whole campus, all divisions, was co-chaired by the two of us and ran its activities in 2017 and 2018. And the committee was tasked to answer two questions. How should the University of Chicago approach this new area? And the second, should we just focus on some new degree programs, or is data science a new field of knowledge? The committee immediately converged on recommending to the university to recognize and develop data science as an emerging new discipline, and also endorse the following: to pursue a university-wide effort that leverages university strengths and encourages crossings of disciplinary boundaries, to develop and coordinate undergraduate and graduate education programs, to foster engagement with industry concentrated on data science innovation, research and education, and to focus on foundational research and acceleration of AI and data-driven discovery across all fields of inquiry. Over the years, the faculty in computer science, statistics, and other units on campus have built on the committee recommendations and achieved many of its proposed goals, from research initiatives to education programs and partnerships with industry, academia, and nonprofits. And all have been guided by our distinctive vision for data science. University of Chicago has a history of pioneering school of thoughts in areas such as economics, sociology, and urban studies. And not only that, but the university has top research programs across the social, physical, and biological sciences, faculty who work on understanding deep theoretical issues and then develop that theory to strengthen, broaden, and amplify the efficacy of their application, and an exceptional interdisciplinary climate that will position us well to address the fundamental societal questions posed by the data revolution. These strengths make University of Chicago uniquely poised to define the field of data science and be an intellectual leader in this still evolving field.
So let me tell you a little bit about our vision for data science. The vision starts with the recognition, as you've heard, that data science, we believe, is a new scientific discipline. This perspective opens opportunities for innovation and real-world impact that go beyond a simple merging of its existing methodologies, as is being pursued by many other institutions across the world. Instead, we've taken a holistic approach to data science. In our view, the data science comprises innovations within and at the interfaces of computer science, statistics, and machine learning, but it's also augmented in several key ways. First, our vision of data science recognizes that a primary purpose of data analysis and modeling is to influence decision-making. Thus, we identify human-centered concerns of communication, transparency, and explainability to be central to the field, on an equal footing to the purely technological considerations. Secondly, as the world is quickly learning, acquiring and exploiting data without considering the societal implications of doing so leads to unintended and detrimental impacts on individuals and society as a whole. Misuse of data has the potential to undermine political discourse and exacerbate inequities. Thus, UChicago's vision of data science embeds attention to the societal implications in our research, education, and outreach. We partner with colleagues in the humanities, social sciences, policy, law, and elsewhere on campus to bring this broader perspective to the field. Finally, if data science really is a new discipline, as we've proposed, then there must be foundational questions that are either being inadequately addressed or maybe not even being asked at all, because they fall between the cracks of existing fields of study. We've identified as a group a number of such foundational questions, ranging from things like the methodological implications of merging statistical and logic-based perspectives on data, understanding the economic laws that will drive the new data economy, and asking fundamental questions about scalability, uncertainty, privacy, ethics, and reproducibility that arise when working with vast amounts of data. This holistic vision of a new field leads to a distinctive approach to data science and is why we believe that there's no better place than UChicago to pursue this new area.
So the Institute will not only continue to define the field of data science, but also aims to build a world-leading academic unit. To advance data-driven education, discovery, and innovation, the Data Science Institute has focused on recruiting junior and senior faculty who will advance the core foundational and methodological areas and or lead in several key domains of applications. Some of them are in this room. The Institute has empowered data science research across the university through seed grants and research initiatives with the aim to attract top graduate students and postdocs and enable undergraduates to participate in data-intensive research, and also pioneer a new model in data science education. The components include the major and the minor, programs for the undergraduates, a PhD-level committee for graduate programs, and PhD certificates for doctoral students across campus. Finally, data science is happening everywhere on campus, and the Institute aspiration is to become an intellectual center of gravity for this activity, one that is built for interaction and engagement across the breadth of endeavors on campus. We plan to continue to learn, not only from our university collaborators, but also from all our collaborators and partners from academia, industry, and nonprofits. Before Mike introduces our next speaker, we would like to thank the PSD Dean, Angela Olinto, for her unabated encouragement, Provost Kai Lee and the Office of the Provost, including Mike Hopkins, for their deep trust in our vision and their support in implementing it, Chancellor Robert Zimmer for his continued support and mentorship, and for guiding us through thinking about the right approach for a campus-wide initiative, and President Paul Alivisatos will be here later today, whose vision for a modern, engaged university is creating an environment where our programs will flourish.
So in some sense, creating the DSI vision and ambition was really the easy part. And the next step is making it a reality. So we've set an aggressive pace of expansion, and we're rapidly building out new programs, which you'll hear about through the course of the afternoon. Our next speaker has been at the center of building the Data Science Institute and executing this vision for data science. So David Ominsky is a senior research associate and the executive director of the Data Science Institute. David was an NSF and UC President's Fellow at UCLA, and in 2015, he was named a National Academy of Sciences Kavli Frontiers of Science Fellow. He was previously at the University of San Francisco, where he was executive director of the Data Institute and directed undergraduate and graduate programs in the area. David joined us in September 2020 to head up the Data Science Institute, and is a major reason why we're all here today. So please join me in welcoming David.
Thank you, Mike and Dan, and thank you, Provost Lee, for the lovely opening remarks. It is the case that a lot of you are here because of some of the work I've been doing. So hopefully it's with celebration today that you're here. Otherwise, I'll send you my email later. You know, when I was first approached about joining the University of Chicago in data science, you know, my first thinking was, I'm comfortably settled in the Bay Area. My family is very happy in our foggy weather. Why would I want to pick up? I've been toiling. I was a math professor at my previous institution, building data institutes and data science programs for a really long time. In fact, in 2013, we launched an undergraduate data science major at that time, which is, now that I think about it, you know, probably would ill fit into the new vision of data science now, and rightfully so, but also very early in thinking about this field. For me, what I thought about of data science was really a way to bring science and mathematics to a community of learners and researchers that maybe would have overlooked thinking about mathematics, computer science, and statistics. So when I was approached by this vision by Mike and Dan, the pitch was really very simple. What if we were as ambitious as we could be? What does that ambition take you at a place like University of Chicago? We've heard words like field defining, and that's real here. And for me, what was very convincing was that this entire picture of data science is really conceptually the no one left behind here. We, of course, are centered in mathematics, statistics, and CS, or say applied mathematics. But as you'll hear for the rest of the day, the entire university is involved in this endeavor. The students from high schoolers all the way to graduate students, postdocs. Field-defining exercises don't come around very often. We're sitting at the precipice of one right now. It was only the University of Chicago that made a compelling case to me, at least willing to pick up in 5 weeks and move cross country to a city I've never visited. I have to say, in doing so, it has been one of the best decisions of my life. You can rank the rest of them up there. Because it brings us here today. It brings a lot of important people together. It brings the opportunity and promise of what we really want to do together. And very real and in a very 3-hour program. So what is our approach to data science? There is a lot of operational aspects that we need to think about, but at our core, we're doing field-defining work. We're also thinking about who's a data scientist. We talked a lot about bringing all this campus together, but success for us looks a lot like who is going to be a data science graduating from the University of Chicago or elsewhere in the university systems. We think very hard and put intentional effort into what we think data science is. We may see a lot of students that may have overlooked a STEM education feeling invited and included in this new effort. If we do that, along with the research we have planned, well, we'll be pretty successful. And so, to carry this out, though, we've taken a 3 pillars approach to this effort. And so those are, oh, great, the slides changed. As was mentioned before, education, outreach, and research. So in education, we're well on our way. Since 2020, we've been working very hard. There's an extraordinarily, minor set in place, and we built a major at the university that launched at the University of Chicago in the fall this past year. The response, as you'll hear from some of the students today, has been incredible. The demand for the introductory data science sequence is something that we have yet to still figure out how to match. For us, this means we've at least put some of the initial pieces in place that are looking really good. The major itself, we hope, is really just the beginning of our educational efforts moving forward. We have plans, of course, already in the works for a PhD program, revolutionizing graduate data science work at large through, as was mentioned, the certificate. But we're also thinking broadly about education. We're going to produce, with intentional and significant effort, the research leaders in data science in this country. But we'll also produce leading educators in data science who are teaching other collegiate students, community college students, high school students, and beyond. We need to think about the impact and thinking about data literacy and the impacts on society much more broadly, much more ambitiously than other attempts at other universities. We've got the master's programs in place. We're thinking about many more. But education right now is one of those opportunities to put out our best foot and think about what should we be thinking when we are producing an educated data scientist out of the University of Chicago. So in addition to education, we're thinking a lot about outreach. And in outreach is one of the critical pieces that we knew would enhance our research and educational efforts. If we're defining a new field, it's pretty easy to acknowledge that we don't have all the important data sets in the world here at the University of Chicago. We also don't have all of those hard questions that are out there that have been looked at for the last 10 years inside the university. So to maximally approach research and field definition, we've got to find bold new ways to get out of the university with our new endeavor and find meaningful, mutually beneficial ways to engage outside the university. We've done a lot of important first steps. I think a lot of the work you're going to hear today is going to represent some of that. Work with the 11th hour, focused on working with over 400 grantees in nonprofits and social change organizations, thinking through how data and data science is changing how nonprofits can elevate and impact the work that they want to do. We're also looking very seriously at the way research engages in outreach, and we're going to talk, and I think what I'll do now is introduce this next group. The first research initiative you're going to hear today is one that is on internet equity and access. And so, joining, internet equity and access. The second will be AI and science, and the third is data and democracy. If the titles alone don't want to keep you in the seat, then I think you probably came into the wrong room. So in order to understand our approach to research, though, it's my great pleasure to invite several people to stage here. There we go. Joining us on stage right now is a person that I have great reverence for and has really been one of the stalwart supporters of data science, and that is our Dean, Angelo Olinto. He's the Dean of the Division of the Physical Sciences and the Albert A. Michelson Distinguished Service Professor in the Department of Astronomy and Astrophysics, the Kavli Institute for Cosmological Physics, and the Enrico Fermi Institute at the University of Chicago. Dean Olinto is known for her contributions to the study of the structure of neutron stars, primordial inflationary theory, cosmic magnetic fields, the nature of dark matter, and the origin of the highest energy cosmos rays, gamma rays and neutrinos. From just hearing that, you can understand why data science might be one of the critical fields that could reach very broadly through PSD. Joining Angela on stage is also our faculty director of research, Nick Feimster, who's a Neubauer professor of computer science. And Nick's research covers network performance, security, privacy, internet censorship, and access. He's one of the principal investigators of the Internet Equity Initiative I just referenced. Joining Nick as well is Professor Rebecca Willett, Professor of Statistics and Computer Science at the University of Chicago and Faculty Director of AI. at the Data Science Institute. Her research is focused on machine learning, signal processing, and large-scale data science. With the DSI, she's leading the AI and Science Research Initiative as well. So please welcome our panelists.
Okay, yes, now I can hear myself. Well, thank you very much for everybody being here, and thank you, David, for the very kind introduction. It's such a pleasure to be here sitting with Becca. Is that okay to call you Becca and Nick? I just wanted to share with you that University of Chicago is very proud of starting new disciplines. You might not know that astrophysics started here. The idea that astronomy and physics together would be a new discipline was something that happened here at the University of Chicago. So bringing statistics and computer science together and making data science to the next century wonderful new discipline is something we are very proud of being able to support. In the physical sciences division, we have many disciplines, including astronomy, astrophysics, and physics, that have generated huge amounts of data. And I think most of any human endeavor these days is matching our efforts, but we started with problems in data science before we knew the name data science. I think given that background, some of the physical sciences division, which has both the mathematical side and the physical experimental-based effort in laboratories, they together have a wonderful fertile ground to bring this not only to fruition in its own right, but also to affect the rest of campus. At the Physical Sciences Division, we have computer science and statistics alongside these other fields that are based more on the laboratory work. And also we have a new effort in applied math and computation applied math. And together we are trying to give a house to all kinds of ways of thinking data science in the future. So we're very excited about that. And I'm even more excited today to be with these two wonderful people here joining me today. And I'll start asking them a few questions, and we'll hear more in depth later from both topics. So let me start with, that's not what I remembered, but but let's start with asking both Nick and Becca, what is the unique elements of the University of Chicago that bring the data science research here?
Great. I think one of the things that really excited me about the University of Chicago when I decided to come here just a couple of years ago was I think some of the administration and leadership talking about the ethos of the university and defining fields and data science being one of them at the top of the agenda. And I think that coupled with a strong history of doing research and scholarship with social impact and outreach, the type of things David spoke about, just struck me as a unique competitive advantage for us in this area. I think in particular, the university has a strong history in civic engagement, a strong history in free expression, and extremely strong scholarship in areas of public policy, law, and so forth. And I think we are seeing the intersection of all of those areas with data science. And so, just this past week or a couple weeks ago, I think there was an acquisition of a social media company, right? And if you haven't been paying attention, one of the things right at the nexus there is content moderation and free expression. Who is going to be able to talk about the data that is being produced on these platforms, how it's being moderated, who has access to that, what happens as a result of people's access to that information? That's a question that intersects data science, computer science, policy, law, sociology, many other fields. And I think this university is uniquely situated to answer questions like that. I think as Mike Franklin told me when he was convincing me to come here, he said, this university has so many top-notch pieces of the puzzle, it's just up to us to put them together. And I think that's what this institute is doing.
Those are, oh, sorry, go ahead.
No, just thank you, Nick. Please back up.
Yeah, those are great points, and I completely agree. I would just complement that by saying that UChicago also has a strong track record of really focusing on foundations, on developing the core underpinnings and theory of many different fields. And so I think that's really going to play to our strengths as well as we develop this Data Science Institute in this emerging field. And to complement what Nick said about working with the social sciences and policy and law, we also have a really special opportunity here to work with people in the natural sciences, people who have been dealing with large quantities of data in novel and unique ways for a long time and very successfully. And so here we're going to be able to not only advance the foundations of data science, artificial intelligence, and machine learning, but also work with people who are using these tools in real-world settings and have broad impact. I think all of these things together in both of our areas just go to emphasize the point that data science in isolation will have relatively limited impact. But the integrative approach that we're developing here at the University of Chicago, involving top scholars in a number of different fields, is going to be distinctive and just world-changing.
Thank you, Becca. So let me ask a couple questions directly. So for Nick, the Data Science Institute evolved out something called the Center for Data and Computing that we call CDEC, and you were the faculty director of that center. So tell us a little bit about how your future vision for integrating CDEC into DSI.
Great. I see we have a limited time, so I'll try to do it as a speed round. So I think when I was brought here to help launch some of the research initiatives at CDEC, one of the missions was to bring different aspects across campus, different disciplines, different departments, different fields of expertise together to work on problems at the intersection of data, society, science, and so forth. And I think the center succeeded in doing that, and I think the mission there continues. Right? I think we view the Data Science Institute as the nexus for data-driven research on campus.
Great, and let's just jump into Becca for the artificial intelligence side of data science. What are your thoughts in there?
Yeah, great. Yeah, many people have asked us, well, how does artificial intelligence relate to data science? And of course, these are have emerging definitions. But we can think often of artificial intelligence as being the tools by which we try to learn patterns and make predictions using samples or using data. And here at UChicago, the way that we are developing data science, it's taking into account these challenges of artificial intelligence within a very broad context. So not only thinking about the fundamental machine learning challenges, but also thinking about how do we collect our data and sample it and ensure that it's got as little bias as possible. How do we store that data and ensure that the privacy of the people who are represented by that data is protected? Or how do we transmit it, especially when data is stored in data centers that might be distributed nationally or internationally? And so I think, a couple of years ago, we had someone visit us from IBM, and he was telling us that their machine learning team would develop methods, and then they deploy them in the real world, and it wouldn't work nearly as well as expected. And it took them a while to figure out why, but it turned out that the people who were collecting and pre-processing the data were inducing something that we call data leakage. So they were kind of like taking a sneak peek at the test before they were tested. And as a result, they were getting inflated ideas of how well their tools were actually going to work in practice. And it was an artifact of the fact that they weren't thinking about all of these different elements of data science holistically as an integrative team. And that's a challenge that I think the Data Science Institute here is directly addressing by thinking about these myriad challenges all together with interdisciplinary teams.
Thank you. So to both of you, what are you imagining 10 years from now will be a success story for this initiative?
Sure. I think the mission as we set out, right, was to develop a discipline, to develop a language. And I think one of the things that I learned upon coming here and taking this up was that, wow, we already have that language, right? Despite the wide range of disciplines that we work on, we talk about data in similar ways. We deal with issues of compression, we deal with issues of uncertainty, we deal with issues of sampling, bias, we deal with issues of how to derive insight from an inference, or how to derive insight from data. And we're just getting started. I think if you talk to either of us, and I guess we'll have subsequent panels on various research deep dives, the questions that we don't know the answers to, and what data can or can't tell us about those questions of just central importance to society, the questions far outnumber the answers at this point. And so I think 10 years ahead, this will be the discipline that I think everybody has to study at least a little bit. There's just no way, I think, to be literate in today's society without being somewhat versed in this area.
I think that's exactly right. And I think in addition to it being a really exciting academic discipline, this is something that's really touching all of our lives, from self-driving cars to agriculture to healthcare decision-making, like Tom was talking about during lunch, to finance and criminal justice. And another area that is emphasized by the Data Science Institute is the natural sciences. And we really see that in the next 10, I know we will see in the next 10 years, that data science will become an integral part of the scientific method. And so to maybe adapt a quote that Tom used during our lunch talk, AI won't replace the scientists, but scientists who use AI will replace those who don't. Thank you.
That was a good quote. So thank you so much, both of you, for being here, for leading, having this vision ahead, and we will have more of you later in panel discussions. So thank you so much, and
Thank you.
good luck to
Thanks.
everybody.
Thanks.
Thank you. So we'll be turning now briefly to from research to education. And here again, as one of our central pillars, is the way we're going to think about training the next generation of data science researchers, educators, and practitioners. Joining us on stage, in addition to Mike Franklin, who will be moderating the panel, and Dan Nicolai, is Steve Levitt, who is the William B. Ogden Distinguished Service Professor in Economics and the college. Steve is one of the nation's leading microeconomists, has done pioneering and influential work on national experiments in economics, including the economic aspects of crime, corruption, and education. He's the co-author of the book you might have heard about, For Economics, and received the John Bates Clark Medal in 2004. Please join this panel. I'm very excited to hear what they have in store for us.
Okay, great. Well, let's get right to it. So we're going to do a series of panels. I guess this is the middle one, focused on the three main pillars of the Institute, and this topic is education. And so I'm just jumping in. So the first question I have for both of you is, what makes a good data scientist, and what do prospective data scientists need to learn? And whoever wants to go.
So we can spend some time talking about the mathematical, statistical, computational, machine learning aspects of what makes a good data scientist. And obviously the level of knowledge will depend on the employer and the domain of application. But what I think makes a data scientist exceptional is something I called data common sense. And data common sense include, among others, three components. The first one is domain knowledge. The second one is understanding and appreciating the impact of data and analysis. And the third one is communicating with data. So domain knowledge, I think it's self-explanatory. It's about understanding the context of the analysis, of the projects, understanding the big questions in that domain, and how the big hypotheses and how those impact data collection and data analysis. And also understanding the broader context, other data sets that can be used in order to enhance a data science project. In terms of impact, this includes everything around ethics, privacy, transparency, fairness. And these are clearly very important. I believe that ethics is important for any STEM education, but it's acutely important for data science, where algorithms and methods can make impactful decisions. We all know about algorithms that influence decisions such as who gets what medical treatment, who gets out on bail, who gets a loan. And obviously, sort of understanding that impact is essential for a data scientist. And finally, communicating with data is not only about data visualization, it's about data scientists being able to explain assumptions that go into their analysis, being able to clearly communicate issues around robustness, uncertainty, confidence, and so on.
I'd agree with everything Dan said. I would add one thing. I have a friend who's high up at Facebook and has a team of 20 data engineers who work for her. And she called me the other day and she said, I just realized that in 2 years of managing 20 data engineers, they have not had one single idea about a good question to ask. And I think a really critical piece of data science is asking the right questions of the data. And there's more of an art form. It's something unusual about it. It's like somehow a mix of art and science and taste and judgment, which I think is really fascinating in the education domain, because I honestly think we have no idea how to teach people to be data scientists. I think we haven't really even tried. And that's the thing that intrigues me so much about what you're doing, is that if we can figure out here how to train data scientists. Like it's easy to teach people how to program a computer, right? So we have figured that out. The market has figured out, if you want to learn how to program R, you can go online, and within 3 months, you'll be like kind of a decent programmer of R. I challenge anyone to go off on the internet and 3 months later come back being an excellent data scientist. And so I think we really have a challenge in front of us on the education front here.
Great. Okay, well, good. So following up on that, Dan, you just designed and launched a data science major. So how do these types of considerations fit into the major?
So the data science major, it's in many ways similar to the computer science and the statistics major, in the sense that it starts by building the mathematical, computational foundations for data science. But it's different for the reasons that we just discussed, right? We have a big emphasis on machine learning and artificial intelligence, and that's obvious. But we also sort of try to cultivate this data common sense skills that I was just talking about. So we have a big emphasis on data ethics and privacy. We have courses designed in order to educate students on that. We have a big emphasis on communication and data visualization, and talking about statistical and data science pitfalls. So that's another part of it. But I think what's most distinctive about our major is the emphasis on experiential learning, right? And that starts early on in the first 2 courses the students take. These are the 2 courses that Mike and I created, where students work on real-world problem and on projects. And they culminate in something we called the Data Science Clinic, which is a sequence of 2 courses. It serves like a capstone, and the students take it as seniors. And in those 2 courses, students work in teams on real-world projects, and they are tasked to deliver solutions, software, apps, research reports, and so on. And they do all of this working under the mentorship of faculty or research staff on problems that come from our partners in academia, in industry, and nonprofits, so real-world problems. So one more thing I would like to say about the data science major is that we were very thoughtful in the way we built it, in trying to because we realized that there will be a diversity of students interested in data science. So we have various tracks in the major. One that targets students that are interested in a more theoretical part of data science, one that's for students who are interested in a more computational track of data science, but one track that's great for students who look at data science as the second major. You know, the University of Chicago students who are doubling majors are slackers. You know, everybody's triple majoring, I think. So the students who only have 2 majors, you know, data science is a great second major, because students come in and learn, you know, skills, tools, methods, algorithms that they can take back to the primary field of interest. So that's
great. Well, following up on that, I think it was Nick who said that in the future, or maybe in the present, to be considered a literate person, you need to understand how to work with data. And so, Steve, how do you see data science impacting undergraduate education at UChicago and elsewhere?
So I was just had the privilege of talking to our incoming freshmen, the whole group, and I started by saying how much we'd improved our economics major, which we have improved our economics major dramatically. But then I said truthfully that I think the data science major and minor, the classes, the education part, is the most important thing that I've seen here in 25 years for the undergrads. It's teaching them a set of skills that are incredibly practical and useful in life and in business, in their jobs. But it's deeper than that because it's a way of thinking. It's just such an important framework for thinking about the modern world that my prediction is that this is going to be 10 years from now is going to be, maybe economics will still be the number major, or maybe economics will be number 2, because I think it's that important and that fundamental. And there's just such a transformation going on that these are skills that everybody should want to have. I think we do face a challenge, however, in that we're not teaching. The high schools are doing such an incredibly poor job of preparing the students in this regard that I think there's a bigger agenda around that I've been working on to try to figure out how to bring these skills down the funnel to grade school kids as well.
Do you want to say anything more about that?
I just think look, I think it's we started something called the Data Science for Everyone, which is trying to figure out how to change high school curricula to bring this in. But ultimately, I think the strongest force in doing that is going to be the realization that when other universities start copying what Chicago is doing, the pressure will just intensify on all parts of the academic funnel to figure out how to deliver this kind of knowledge. And let me say one last thing. The other thing that I think is, I've been so heartened by this initiative, obviously I'm far from the heart of it, I'm really an outsider looking in, is that for data science to really thrive, it's got to thrive in a context, right? So in the abstract, data science is okay, but it's within disciplines that the real power of data science comes in. And I have been so heartened by the way in which you've looked outwards and the way in which you've made this a university-wide initiative. I think there are very few universities that have the kind of communication across disciplines. How many universities does the computer science team talk to the economists? I can't think of another one really. So anyway, to me, that's really makes me even more excited about the possibilities.
Great. All right. Well, I think with that, we're going to wrap up the education panel. But thank you both of you very much for sharing your thoughts with us. And yeah, what's next? Thank you.
So it's probably easy to see that we have 3 pillars, but they're not 3 silos. Even on the education panel, we've heard issues around outreach and research. The work we're doing in outreach is critically important, as I mentioned before. We're really extending past the boundaries of the university to get this work in place. This means to directly engage with our neighbors on the South Side, industry, social impact organizations. Today, you're going to see many examples of that work, and you've started to hear about some already. We've started these new partnerships thoughtfully with the concept of non-extractive practice, mutual beneficiality. This is the way we're going to be able to engage our community. Some of the programs that we won't be able to feature, as you can imagine, we have quite a packed schedule, but one I'm very proud of is the Community Data Fellows. It's a brand new idea, really, for graduate students to figure out a way to engage directly. Like, by directly, I mean just the Community Data Fellow and the organization, and understanding what does it mean to grow data science capacity, data capacity at large. It's questions that we've just heard about around literacy. All organizations right now, industry or otherwise, is feeling the opportunity, but also the pressure of the use of data. And this is an opportunity for the University of Chicago to really lead and think about the way to help not just leading industrial partners, which we have, but also underserved and under-resourced community partners as well. So our next panel, actually, is one that I think exemplifies all 3 pillars quite naturally. And this is the first of our research initiative. The COVID pandemic has drawn attention to what's often called the digital divide. The inequities in access to high-speed internet have become even more essential during this period of time. The Internet Equity and Access Research Initiative is really a research initiative that is the full suite of outreach research problems at the very forefront that are foundational to our understanding of the field. Fundamentally, the question around who should access data, How should society equitably distribute data? This is a question of our time, and it just so happens we have to have a team at the University of Chicago, experts, focused on just this type of problem. So joining me, as I shuffle some papers over, apologies for that, is our Internet Equity Panel, okay, and the first of our research initiatives. First joining us is Julia Lane, who's an Assistant Vice President for Science at the University of Chicago, and until very recently, my own colleague as the Executive Director of Research Programs at the DSI. Joining Julia is Nicole Marwell, who's an Associate Professor in the University of Chicago Crown Family School of Social Work Policy and Practice, and is a Principal Investigator on the DSI Internet Equity Initiative. Joining those two, of course, is someone you've already been quite familiar with, is Nick Beamster. So please join us on stage. Welcome our panel. And I am remiss to say, I could not scroll down fast enough, joining us on stage and a critical member of this entire research initiative and exemplifying how powerful the impact can be is Dwayne Douglas, who's an executive officer of the Quilt Corporation, which operates the Chicago Area Broadband Initiative, an affordable broadband initiative focused on bridging the digital divide in urban underserved communities. Thank you, Dwayne, for joining us as well.
Thank you.
Great. So as David mentioned, the Internet Equity Initiative is one of our research initiatives at the DSI, and these are multi-year initiatives that really are focused on advancing exciting interdisciplinary work that has real-world impact. So I'm so delighted to be talking with my colleagues and friends on this panel. And I want to really, start off this discussion by going first to Nick, I think, and asking a little bit about the approach. So, we hear a lot about the digital divide across the nation, and a lot of organizations have really focused on sort of one-size-fits-all solutions for the digital divide. But with the Internet Equity Initiative, you really focused on much more of a hyper-local focus. And so I'm curious to hear a little bit more about, why did you decide to take this approach and focus on urban communities, specifically in Chicago?
Great question. So I think this is where some of the research meets the personal. So I had worked as an expert in computer networking and network measurement for almost a decade, trying to basically do things like perfect internet speed tests. If you've used speedtest.net, I think our guests from UCLA are here as well, so welcome. But also that's an area where I think our technical community has spent quite a lot of attention. And I think anyone who's worked in that area can look at some of the maps that are produced, some of the maps that are produced by the FCC and elsewhere, and it's no secret that those maps don't often reflect reality. But it really hit home when I moved to Chicago, and when looking at a map from the FCC that basically said things were great right here in Hyde Park, and it took basically quite a bit of leverage for me to get internet access on my own block. And I knew in abstract that the maps were not reflecting reality as a practitioner of the research, but it really hit home when I moved here and had that experience, because I thought, I'm here in Hyde Park. The data suggests that all is well. I just experienced a situation that suggests all is not well. If that's what the situation is here, right in UChicago's backyard, we really start to, we need to start turning over some more rocks here. I bet if we turn over rocks in other communities in Chicago, we're going to basically see that story over and over and over again. And I think that is basically part of what motivated that approach. But I think as we got further and further down the road, we realized that, yes, this is a local problem. This is certainly a problem in Chicago, but it's a neighborhood by neighborhood problem. And I think that's what makes it such an interesting data science question as well. Because if you think about, how are we going to basically understand this problem, everybody, as you mentioned, is looking at it sort of nationwide, trying to boil the ocean with data, but it's surface level. And I think everything I mentioned so far, I think, motivates the approach that we're trying to take to this problem. It brings new data analysis, new data science questions to the forefront, but it's really a community bottom-up effort as well.
That's great. So I want to go to Dwayne next. Dwayne, you lead the Chicago Area Broadband Initiative, also called CABI, and you're a partner of the Internet Equity Initiative. I'd like to hear a little bit more about your approach with internet deployments in Chicago. We live in a big city. I just would be curious, why do we need more deployments?
So what we found with CABI is that one thing we do is we partner with communities. So we partner with communities to understand their needs, their desires, and what their priorities are. All these communities are different. So from the west side of Chicago to the south side of Chicago, they have different needs, different wants, different priorities that they're trying to address. And what we do is we work with these communities to help understand and define for them solutions that can provide more impact to address those community needs. One issue that we found is that, most of the properties within Chicago aren't wired properly to even utilize broadband services. So then you have the issue whereas individuals within these units don't understand why they need access to the internet. Or you have individuals with what we call bandwidth poverty who don't have the resources or the availability of access to see beyond what their current needs are as it relates to food, rent, light, gas, safety within their communities, to even look at those things. So what CABI does is we work with the communities and our partners to reduce those issues for them, to open pathways to access to those to the digital economy and those advantages of it.
Oh, that's really interesting. Just as a follow-up question, I'd be curious to know a little bit more about, you're partnering here with the researchers at UChicago. I'd love to know a little bit more about what kind of research questions are you hoping to address with them? And also just want to say too, this is pretty unique that we have a group of researchers who are partnering with someone who's directly working with the community in Chicago. So that's a pretty remarkable partnership already.
It is, and I really appreciate the opportunity as well. One of the things that I would like to do is to look at creative pathways of to see more awareness, inclusion, community advocacy, to go beyond the top level affordable and awareness data points, but to also address more of the look at more of the urban broadband areas of access and what drives the lack of access within these communities.
That's great. Yeah, going a little bit deeper than just that. It's about affordability in urban areas, but there's a lot of other issues. So kind of building on that comment, I want to go to Nicole next. At the start of the pandemic in the city of Chicago, it looks like more than 100,000 children under the age of 18 lacked access to broadband internet connectivity. And at the time, a lot of the narrative was just about, getting people connected, getting families connected to the internet through subsidy programs. And I'm curious from your perspective, Nicole, is getting connected sort of the challenge that we need to focus on? Is that kind of where we stop after people are connected?
So as you say, getting connected is a huge challenge. And, we really have seen some great efforts in the policy space at the local level here in Chicago. Our partners at the City of Chicago and Chicago Public Schools, Kids First Chicago, they all really sort of moved heaven and earth to work with the internet service providers and make sure that every school child in Chicago Public Schools was offered the opportunity for a free internet connection for a period of up to 4 years. And that was really critical. You can't have a remote learning context when kids are not able to connect and get access to school. And so that first line of getting connected is critically important. I don't want to underplay that. But what we're doing here with the research initiative is we're pivoting to what we think the next question is, right? This speaks to the issue that Steve Levitt raised, how do you frame the right questions? How do you ask the right questions that are interesting? And so we're starting to look more deeply at this much more granular level at what is the infrastructure of the internet actually performing like, right? Is it the case that if you buy a gigabit connection anywhere in the city of Chicago, you're actually getting the same service? And our data that we're collecting now through this initiative is showing us that that may not actually be the case. We're seeing that when people have the same internet service in different neighborhoods in the city, they are not getting the same performance. And so we're really trying to reframe the question about internet equity and say it's not just about can you get everyone connected, which is a huge lift, by the way, but also, what is happening with this infrastructure, which we really can't see. You think about infrastructure like, say, public transit. You can see where the public transit is and where it isn't. It's a lot harder to see where the internet infrastructure is, how well it's performing, and that's the thing that we're really pivoting towards and collecting this continuous measurement data to really be able to say, look, the internet performs like this in these neighborhoods, and it performs differently in other neighborhoods. And so we're really looking to push that question forward.
And that's really exciting. I'm glad you're thinking about sort of the downstream, effects of having internet connectivity or not having it. I want to talk a little bit about partnership. So this initiative, again, is really unique in that it's really focused on partnership at the industry level, at government, at local government, also with community partners as well. I'd love to hear maybe from Nick about, how are you working with these different partners and how can people get involved?
Great. So that's two different questions. Let me just sort of back up a little bit and talk about the question that I think we see a story on the data science website today relates to internet inequity across neighborhoods in Chicago based on an analysis of census data. Now, to I think our previous panelist, Steve Levitt's comment, we didn't think of that question. That came from City of Chicago, right? So that, I think, to me, is what data science is all about. We didn't dream up that question with data just dropped in our lap. We went to the stakeholders, asked them, what do you want to know? And now is that data available to us? If so, let's figure out what the existing data can tell us, what it can't tell us. If it can't tell us something, let's go get better data. And so I think there's an animation here, right? So this is where, in doing that initial study that pointed out the existence of inequity, we said, aha, okay, it exists at a neighborhood level. Thanks for posing that question. But what about going within a neighborhood? What happens census block to census block or household to household? And those are questions that we don't know the answers to. And I think as far as how can people get involved, I think that's an appeal to residents of the city. You can see a heat map here that shows, like, we have now data being gathered across 100 households in 30 neighborhoods across the city. But if you know anything about Chicago, you know there are more than 100 people who live here, and there are also more than 30 neighborhoods. And so that's one way to get involved. But another way to get involved, and I think an appeal to faculty, domain experts, postdocs, students, et cetera, this is a fundamental data sampling question. How many homes do we need to sample to get a good handle on these questions, both where the problems are, what the causes of those problems are, and as the federal government rains $65 billion down on this problem in the next few years, how do we know that it's actually working? So we don't actually have the data to answer any of those questions yet. And unlike something like a population sample, we're talking about an infrastructure sample here. Nobody really knows how to do that. So I think there are all kinds of questions across the disciplines. And so that's an appeal, I think, for students. If you're looking for interesting places to get involved, this is, I think, a very ripe area with a huge potential for impact on society.
Well, great. Well, I think we're about out of time, but I do know you guys launched something very special today. Can you talk a little bit, maybe very briefly, about the portal?
So I think there's a graphic up there that shows the portal. This is the, you can see this at internetequity.uchicago.edu. So this is a portal that releases some of that data that I just described as part of the census level analysis. And there's other stories on there that I think tell you more about, like, what Nicole and Dwayne and I have been talking about as far as, what does internet access look like across the city? How much speed do you actually need to participate in Zoom video conference calls all day long? Not that we would ever have to do that, I suppose, but and so on and so forth. And I think that should give you a sense of where we are, but we are just scratching the surface there. You will see, if you look at those, that you will probably have more questions after reading those data stories than by the end of reading those stories. And so that, again, I think is an open invitation. Participate as a resident of this city, as a member of our community. Participate as a scholar, as a researcher, as a student. Many, many opportunities to get involved here.
Great. Well, I want to thank our panel so much. Can't wait to see what's next for internet equity. Thank you.
Another early Data Science Institute partnership that we are very excited about is with our colleagues at the City Colleges of Chicago. And from the beginning, our educational mission has been about more than just improving data science education at the University of Chicago. And we want to work with schools around Chicago and throughout the country on building a new inclusive data science curricula and programs that bring more students and teachers into the field. Our new preceptor program with the Chicago Community College addresses the urgent need for data science teachers that can amplify career skills and STEM interest at both institutions. So the next panel will be moderated by David Uminsky, and he will be joined by Mark Porter, who is the Provost and Chief Academic Officer at City Colleges of Chicago. He leads efforts to advance student success and quality academic experiences in credit programs and adult education at the 7 city colleges: Truman, Wilbur Wright, Malcolm X, Harold Washington, Kennedy King, Olive Harvey, and Richard J. Daley. He will be joined by Walter Massey, who is an American educator, physicist and executive, president emeritus of the School of the Art Institute of Chicago and of Morehouse College, and trustee chair of the City Colleges of Chicago. During his career, Massey has served as head of the National Science Foundation, director of Argonne National Laboratory, and chairman of Bank of America. He also served in professorial and administrative posts at the University of California, Brown University, University of Chicago, and the University of Illinois. Please.
Thank you. Yeah, and it's comfortable, right? These are comfortable. Yeah. Wise man. Well, thank you again for joining us. I've been really excited about this new partnership, and really my first question is to you, Walter. You spent a decade focusing on improving and expanding STEM education and research in the United States. What do you see over that time are the persistent challenges that still remain today in today's environment?
Been a fantastic conference up to now, David. I congratulate you on putting it together. It's interesting. It sounds like you are addressing in your initiative in data sciences some of the problems that I think that we've seen in science education over the years. One has been, and I'm speaking for all levels, youngsters all the way up to college, especially for youngsters, is to get them to see that science is pertinent to their lives and at a level that they can understand. Some interactive, hands-on, engaged, experiential, the word was used here in the sciences. And that's something that we have learned, I think, in all branches of science now, but it hasn't been as implemented to the degree that I think it could be or should be. And it sounds like the way you're thinking about it, you might address it. Also, the field itself, I was really struck that you're going to use, it's an opportunity to use real life problems in teaching the discipline. And I think that other disciplines might learn from what you are doing, as a matter of fact, to improve the quality of teaching. The other thing that has not worked, that has been a persistent problem, is this kind of weeding out mentality that we have had in the sciences. That introductory courses have been designed quite often to weed out students as a filter rather than as a point of attraction. So that's something also it seems like you have thought of and are addressing. I may say a little more about that later on another question. The other is financial support, especially for the kinds of students like you got at city colleges or students from underrepresented groups. That's something that's quite overlooked. They won't go into the sciences because they may need support. They may need to work in college or even in high school, so they don't think that they have the time to devote to what it requires in the sciences. And they often don't see the scientific disciplines as leading to a kind of career that they can appreciate that would be economically supportive for them. So those are three things that come to mind. And it's interesting that I say it sounds like you might have a way to address those.
Certainly doing our best. Thank you, Walter. Dr. Potter, in overseeing the 7 city colleges, what have you observed in your student communities and needs, particularly around STEM? I think we heard Dr. Massey talk quite significantly about some of those overlapping issues. But more specifically to computing, data science, what are the challenges in meeting those needs?
Yeah, so when we look at demand for STEM, computing, data science programs at City Colleges of Chicago, we're seeing that demand come from a few different directions, which is not surprising, understanding that our organization is embedded throughout neighborhoods in Chicago, and we serve a very diverse student body. We see adult learners interested in upskilling and reskilling, looking primarily for programs that are of short duration, that are closely tied and integrated with career opportunity, that will lead to a credential of economic value, that will help them advance in the workplace. And for these learners, oftentimes they are agnostic in thinking whether they want to be in a credit program working toward a degree, or a non-credit program that is just going to get them that next step in their career. And incidentally, in cybersecurity, if you go back 5-6 years ago to our first cybersecurity programs at City Colleges of Chicago, they were just that, these continuing education boot camps that were non-credit. We still have those, but we've added then to the repertoire our degree programs too. And then we see demand coming from our traditional age students who are STEM focused, who may be STEM curious. They may need some convincing, as you mentioned, Walter, that science is pertinent to them, but they're open to those science and computing and tech type programs. For these students, it's really important that we present pathways that both are relevant and lead to good paying jobs, if that's what they are seeking to do, or that allow them to transfer then to a 4-year university. So we kind of have to be, I don't want to say all things to all people because that would be too broad, but it's incumbent upon us to ensure that we have the relevant multiple different pathways that meet these different sources of demand coming.
Thank you, Mark. I think you really highlighted those challenges. I was fortunate when to meet, actually, I think it was very brief. It was a Zoom meeting. I don't know if we count those anymore, but it was just about a month on to the job that I got here. It was a joint UChicago and community college meeting. And there was a lot of discussion around partnership. And what I had heard, near the end of that talk was a real demand around computing and data and STEM education. And the main challenges when we had follow-up conversations was there was significant demand there, and it is very challenging to recruit faculty to the community colleges, as well as we'll attest, even faculty at the University of Chicago, to come and lead in those programs. So once we had really identified a way to work together, for me, what was really exciting was the launch of this preceptorship program. And so what this really is making a statement that says there are opportunities for both of our universities to grow together in the field of data science. So we have, as part of our mission, want to lead and develop the next generation of education leaders in data science, and I think we heard a lot about that earlier. But what that means is new faculty that are as able to teach UChicago data science as they are capable of teaching data science and computing at the community colleges. That is a faculty member that really understands the landscape of education. And it took a lot of work, I think, to get that stood up. And what I'm excited to say is that there are, we put out the call for them, and there's 3 exciting new preceptors joining, and they'll be engaged in both of our institutions in this field building exercise. So given that, Mark, can you sort of, elucidate a little bit more, where's the benefit in this type of capacity building?
Yeah, thanks, David. We're on a learning journey at City Colleges of Chicago in this area of data science as in many other areas. And so the benefits for us are direct in that area of our organizational learning, and then there are some downstream benefits. So the direct benefits are that, first of all, our students are going to benefit from the preceptor assignments for teaching our classes. We're going to begin at Truman College, and our students will have that opportunity to be taught by University of Chicago postdoctoral appointments. But these preceptors will also have a service component, and they will be embedded into the culture at City Colleges of Chicago. We heard earlier Steve Levitt explain how we don't really know how to teach data science because of the newness of the field, the ambiguities that are part of the field. And so that's the learning journey that we'll be on with the preceptors, who will help inform our curriculum, who will help us to learn how to teach data science. And so there will be a lot of really good, strong, significant benefit in that capacity building sense at City Colleges. And then downstream, we're building the new workforce for City Colleges of Chicago. It is not a given that somebody coming out of a PhD program at a top university has the talents and skills to teach at a community college. And this program is designed specifically to develop those types of skills and build that workforce for City Colleges of Chicago and other institutions like it.
Thank you, Mark. Well, I want to end with a question for Walter. Again, it's not often that a new field of science comes along, and we've been talking a lot about that. You know, as data science, as it matures, how do we avoid the mistakes of the past and enable a more diverse and inclusive scientific community in this field?
I think what's going to happen here is older disciplines might learn something from you. You will learn to avoid some of the mistakes. But first, I want to say just a plug for City Colleges. Have you heard? I've done a number of things throughout my life, but I have to say this is one of the most satisfying engagements I've ever had. And the impact that these institutions have on the city, I think, is really not as well known as it ought to be. And this program is going to help in that regard. One of the mistakes in the past is something I alluded to earlier, the mentality that only a few people can do science, and that our job in institutions is to identify those few people and to design courses so that we know who they are, rather than the attitude is that anybody, we would say, most basic, that have basic abilities can do science if we teach it appropriately. And in fact, it's our job to move those students along. It's not their job to fight their way through the system. I think the program with City Colleges, you're going to learn something about how to teach students from all abilities and backgrounds. And maybe, and it sounds like, again, that you are thinking about designing courses that will bring students from different levels, different preparedness, and you're going to teach it in a way that students can move along maybe at different paces, different abilities. So that's something I think we can learn from. The other, I'm not sure we could have done this better. We are doing it in the traditional fields, but the emphasis on the ethical and cultural implications of what you're teaching. And this discipline, and this new discipline, it's so obvious, I think, as everyone has pointed out, most people who've spoken and our luncheon speaker pointed it out, that you have to address it. Well, there are ethical implications to what we teach in all of the scientific disciplines and engineering and math. And we might learn from what you are trying to do here, how to build that more into the disciplines that we teach now. But it sounds like you're on your way to avoiding many of the mistakes, or at least you're preparing a laboratory to test whether there's a way to maybe not avoid those mistakes, but to improve upon ways that we can get around them in the future.
Thank you both so much for joining us.
That was an inspiring panel. So for the next session, we will move on to another research aspect of our initiative. In just 4 years, the Data Science Institute and its predecessor, the Center for Data and Computing, has built collaborations all across campus. We have funded projects that bring new approaches for data science to bear on scientific questions in the social, physical, and biological sciences, arts, economics, and engineering. Faculty at UChicago Medicine have developed impressive data-driven efforts, such as the Medical Imaging and Data Research Center by Mary Ellen Geiger, and the Center for Translational Data Science led by Robert Grossman. In our next segment, we'd like to feature another DSI-funded collaboration that brought together a large team of researchers from medicine, Argonne National Labs, sociology, computer science, and data science. To talk about these projects, I will invite Sam Volkenbaum, who's an associate professor of pediatrics and the associate chief informatics officer for the Biological Sciences Division at the University of Chicago. He's the dean for master's programs, and he designed and launched the UChicago's Masters in Biomedical Informatics. His clinical specialty is pediatric hematology and oncology, caring for kids with cancer and blood diseases, and he's the director of informatics core for the Clinical and Translational Science Award, CTSA, and the UChicago Clinical Informatics Fellowship Program. Sam?
All right, thanks, Dan, and thanks for the opportunity to come speak here today. So, you know, we've gotten pretty good at understanding the medical aspects of a lot of the diseases we treat. If I see a child with leukemia, we are really good at the genomic sequencing and understanding exactly the kinds of treatment that that child needs to cure that child. What we're not good at is understanding what's not in the medicine. How far does that child live away from a pharmacy? Do they live in a happy household? Is there a lot of pollution or mold in their house? These non-clinical factors are extremely important, and they, they make up what we call the sociome. And this is what this project is about, is to address these non-clinical factors to try to understand how they impact disease. Think about a child who lives in the upper left in a condo over the highway. And think about a child who lives out in the suburbs in that beautiful house, and they both have asthma. Their outcomes might be quite different, and yet their asthma may be biologically very similar. And trying to understand the differences and what affects those kids is what this project is really all about. We want to model these non-clinical factors, and it's not just the social determinants of health, which of course are key to understanding these differences, but it's other things. If, for instance, let's say you put a Fitbit on a kid, or you put a Fitbit on somebody and it shows that they do a lot of activity. Is that activity because they have a job that requires them to be in construction, or is that activity because they're marathon training? I think you would agree that although they show a lot of activity, that doesn't necessarily equate to the same kind of exertion. So understanding the sociome is extremely important, and part of the sociome is understanding the structural elements that have led to these differences. The structural elements that lead to people living with different access to food, or living in areas that have higher or lower levels of pollution. These factors interact with the biology in ways that we don't understand yet, in ways that we hope to learn. A major focus of our new Institute for Translational Medicine grant is to study these factors and understand how these lead to inequities in outcome in medicine. So we've had some very generous funding from the Data Science Institute and prior to that, CDAC, and we've been able to build a multidisciplinary team that is very unique to UChicago, and I can't think of any other place where you can bring together social sciences, computer science, biological sciences, population health, also working with the city of Chicago and the state of Illinois, working with Argonne Labs and working with the community to build a multidisciplinary team to study this question that we're piloting, of course, in kids with asthma, but that we hope to expand to many other areas. On the next slide, you'll see what our data look like. This is just an example on the far left, is mapping out a whole different set of different types of data around Chicago. Things like weather, crime, noise, pollution. Those are obvious things to study, right? But what about distance from public transportation, or where there's grocery stores, or where there's a number of foreclosures, or where there's flu shot locations, or WIC locations? These are all different data sets that we can attempt to bring into our data set and model. On the second panel is a project from our geospatial group where they mapped every tree in Chicago. So you can now look at tree canopy and understand who's being exposed to what types of green space. The right two panels are some data that Sanjay Krishnan gave me, the work that he's doing, looking at the amount of poverty in the third panel, showing the different areas of poverty in Chicago, and the association that those areas have with the missingness or the sparseness of the data that we have. So not only are we trying to collect data in areas where they don't have good access, we're finding out that those areas don't have great data. So how do you make up for those differences? How do you account for that as you build your models? And these are all extremely important as we try to think about building this data set for pediatric asthma. But we don't want to build a one-off project. We don't want to build the asthma Sociome data commons. You know, people build one-off projects. We want to build the system so that when the migraine researcher comes along and wants to study how pollen counts affects migraines, they can bring their data and they can plug it in. So what we're doing for asthma is we're taking data from the electronic health record, we're geocoding those kids, and we're mapping it to all these different factors so that we can model outcomes in asthma based on these Sociome factors, but at the same time build the infrastructure to power the next generation of this type of work. So on the next slide, just going back to this picture, we want to build something that's scalable. We want to make it easy for groups to bring their own data. But at the same time, we want to think about ways to solve these problems. You know, maybe it's something as simple as changing the way that a child goes to school in the morning. Maybe because they walk through a high pollution area, that's enough to trigger their asthma. And maybe if we could reroute the way they walk through an area where there's more green space, it would make a difference. So some of the work we're doing is actually with city planners and trying to understand how can we affect a child's outcome by just changing some very small factors about their lives. So I think this represents to me the quintessential kind of study you can do here when you bring together this multidisciplinary group of people, which would be nearly impossible at every other institution that I've worked at. And the way that the DSI is funding these types of projects, bringing these groups together, and then moving ahead to think about industry collaboration and how can we share these data, how can we get other data sets, is really revolutionary, and it's going to change the way that we think about doing these types of studies. So with that, I'll end, and looking forward to further discussion, and I'm really excited to be part of the DSI work. So thank you very much.
Over from research to a bit of outreach and education, I'm delighted to introduce Danil Mikhailov, the Executive Director of Data.org, a nonprofit launched by the MasterCard Center for Inclusive Growth and the Rockefeller Foundation. It envisions a world that uses the power of data science to tackle society's greatest challenges and improve lives across the globe. Prior to Data.org, Danil was at the Wellcome Trust, where he founded and chaired the Digital Strategy Forum for Science, Art, and Culture in the United Kingdom. I think I skipped a few lines on the teleprompter. Either way, Danil is still a social scientist and holds a PhD in sociology and communications, and I'm delighted to welcome him to the podium, if he's here.
Thank you all. It is a great honor to be here. And it is strange. I know how you feel. After 2 years of doing Zoom only, I'm looking for the unmute button before I do this presentation. So bear with me. But it's a great honor to be here. We are really happy to have representatives. So it starts with a different slide. Excellent. So I'll look at the teleprompter instead. So at Data.org, part of our mission is to convene and connect the broader data science community. We're very excited to welcome the Data Science Institute into that global community and honored to be among the very first partners. In early 2021, we funded the Internet Equity Project we heard about earlier today from our Inclusive Growth and Recovery Challenge. It was great working with Nick and his team. Really excited by how much they've grown over that past year. Today, we're very proud to join the DSI in unveiling the new National Data Science Education Network, a consortium of minority-serving institutions from across the United States funded by Data.org and its Capacity Accelerator Network. This effort, led by the University of Chicago Data Science Institute, will create a modular experiential data science curriculum geared towards financial inclusion, including programs based on the DSI Clinic and Summer Lab. So the founding partners of this network are University of Chicago, Howard University, the University of Illinois Chicago, Morehouse College, Fresno State University, North Carolina State University, and the University of Texas at San Antonio, and the City Colleges of Chicago. Such an amazing roster of great educational centers. We're happy to have representatives from these schools here with us today. I am pleased to introduce this next panel, moderated by David Uminsky of UChicago, featuring 3 members of the network. So first of all, Nathan Alexander is an assistant professor of data science and interdisciplinary studies at Morehouse University, and he teaches courses in mathematics, computational methods, and education. His work explores the development of critical and justice-oriented practices in quantitative literacy development. At Morehouse, Dr. Alexander directs the Quantitative Histories Workshop, a community-centered teaching and learning lab for students and faculty to the Atlanta University Center. Next, I want to introduce Maria Banuelos, who is an assistant professor and associate chair of mathematics at Fresno State University. His research group focuses on mathematical biology, optimization, statistical models for genome evolution, and data science. As a program director at the SIAM Activity Group on Applied Math Education and a member of SACNA's DEI subcommittee, he is committed to improving equitable teaching policies in higher education, specifically in the computational sciences. And finally, I want to welcome Amy Yeboah Kwarkume, who is the daughter of Africa, a scholar, filmmaker, and associate professor of Africana Studies at the Department of Afro-American Studies at Howard University. She holds a PhD in African American Studies, 2 Masters of Arts in Sociology and African American Studies, and a forthcoming certificate in data science. Her work as a data scientist centers around AI bias, data inequity, and environmental justice. Please welcome.
Thank you all for coming, and in fact, they all really had to journey quite far to get here, so really extra appreciation. I'm going to start with you, Nathan, just because you're farthest from me. Again, please tell us about your research exploring historical development of community and justice-oriented practice in quantitative literacy. We've heard quite a bit already today on this topic. And then how does this opportunity of joining this network really enhance and amplify the data science efforts going on at Morehouse?
Well, first, David, I want to thank you for having me on the panel, and is it afternoon yet? Good afternoon, everyone. So my lab is the Quantitative Histories Workshop, and one of the things that we focus on in terms of the history and culture is really looking at the local context, and I think a few of the other panelists have talked about that. I'm not sure if you all are aware, but if you Google on your phones now, Du Bois infographics, you know, we see at the turn of the century in 1900, Du Bois, right where we are, Morehouse College and Atlanta University Center, was using data science, I think, to shift the narrative around African Americans specifically. And as Dr. Massey said, who's our 9th president of Morehouse College, you know, a lot of what we're attempting to do is to really redirect students back to STEM and sort of seeing those historical examples where you have quantification and data science being used. I think broadly from a collegiate aspect when it comes to data science as a part of the network, one really important piece here is this historical relevance of how historically Black colleges and universities, tribal colleges and universities, and minority-serving institutions have really served their local communities. And so I think using data science to really think about not just the ethical implications, but what does that mean materially? And Du Bois used something that's called car window sociology. And so every day, many of us pass persons experiencing housing insecurity. And one of our processes is really thinking, what does that mean for us on a day-to-day basis? You know, how do we really put the ethics on us sort of in the hour, in the moment, in the week, and what does that look like when we use the data to support that?
Thank you, Nathan. Very inspiring. I'm excited to get to work. We're actually working a half day tomorrow just on the grant work since everyone's here. Question for you, Amy. Again, I think you have really representative, true multidisciplinary data scientists. You're training in Africana studies. You know, I'm really curious how that has really merged with your efforts in data science, in particular, how it shapes some of your research questions centering on AI bias and data inequality. And if you have time after that, tell us as well how this new network of faculty and PIs can enhance the work being done at Howard in data science.
Great, thank you for that question. I think I'll do the last question first. They say if you want to go fast, you go alone. If you want to go far, you go together. So the idea of partnering with the center at Howard University has allowed us to think about how we can go far with data science. Speaking about how it's been a new field and it's kind of exploding everywhere, We also know that historically, data science has not had the best relationship with African Americans. Knowing and thinking about what happened recently with COVID and being left out. Historically, the algorithms such as thinking of African Americans as 3/5 of a human being that historically have hindered us, and tackling those questions are ways in which we look to partner with the center. Coming from an Africana Studies standpoint, looking at people, place, and culture, with data science, what excites me is about asking the questions that many people don't ask, right? Thinking about how do we deal with communities that are missing in the data, thinking about not just STEM and non-STEM, but people who have experienced science in a dirty way, and kind of granting them access to lean in and ask different questions that haven't been asked. So coming from Africana Studies, it's been exciting. It's not the easiest thing to go from history to Python or R and coding, but just knowing that young kids at Howard in our middle school or students in the DC area can think about things that are happening to them, but also be empowered to find ways to improve their circumstances. So at our new center, we're launching soon. We're dealing with social justice, health equity, economic empowerment, and also the fourth one is, I can't remember the fourth one, environmental justice, right? Just knowing that some of the ways in which data science has exploded, we still have fundamental core problems that exist. As much as the economy is changing, people still lack funds and money. As much as the environmental algorithms are expanding ways for us to find ways to grow food better, people are still hungry. So just kind of dealing with those community level questions that many of us have been left out of, allowing our communities to lean in is very empowering and very powerful. So we're excited about the partnership, and we're excited to allow more of our students to kind of take a handle on data science in a powerful way.
Thank you, Amy. I think we're hearing a lot about missingness of data. We worry about things like bias, but what we're really also hearing is who's left out and what's not being represented in the data. And I think if that's one common takeaway we've heard already, it's one that we should all take home and think significantly about. I mean, it's also great to hear about, you know, how much this is going to impact students is really one of the core focus. Well, Mario, I have a question for you. You know, your students at Fresno State seem very involved already in data science research at the intersection of machine learning, genomics. Can you talk about, you know, how you've been so successful getting your students involved in that kind of work, and also how is this network of new faculty, you know, potentially enhancing those opportunities?
For sure, yeah, and thank you again for giving me this opportunity to be a part of the panel. For some context, the computational offerings at Fresno State, when I first got there in 2018, were very limited to traditional applied mathematics or numerical analysis. And so now, based on student feedback, they wanted to see courses that were, you know, applied to their daily lives. So we started mathematical software and programming course. And so this gives some background because students needed that to be successful in the research I do in genomics and machine learning. And so they had to bring something to the table, either biology or mathematics or computation. Most of the time it was computation. I went to Fresno State as an undergrad, and those experiences weren't offered to me as an undergrad. So now coming back as a professor, I'm able to offer that back. I think for the research part on why it's successful is that we spend a lot of time talking about what does the mentor-mentee agreement look like, because it's not me just with all the knowledge, it's us building a relationship together and understanding, like, let's set up appropriate boundaries, and what does it mean for conflict resolution if we have that conflict in a research setting. So I think that's in large part what makes it successful, and including an aspect of community. For sure. So just as a research community, building that up. And the other part, for the second part of your question, in addition to improving or increasing the resources that students and I would have for research, I hope that they get to experience what a community of researchers are and how those researchers can affect their own community. Because a lot of the times we talk a lot about data science, but that's going to be perceived in a certain way, especially like where I'm from. It's a more rural community. It's perceived as you go in tech, and that's going to look different at Fresno. It's going to look different at Chicago. All right, so I think one of the lessons I learned from the pandemic was kind of echoing Amy's words is, you can't do it alone. You have to have community for everything.
Thank you, Mario, and thank you, panelists. I'm really excited about the work we have. It's going to be hard work, hopefully a labor of love. We have actually PIs from all the rest of the institutions here today as well. We only had three more chairs, so apologies for those that couldn't make it up here. Let's thank our panelists one more time.
We've already heard a lot, but we still have more to come. We'll hear from our panelists on AI and science, data and democracy, the 11th Hour Project, plus President Alivisatos. But for right now, I'm very delighted to announce that we have a 15-minute break. So we'll see you back here at about 4:05. Thanks.
Welcome back, everyone. Welcome back. Welcome back. Welcome back. Welcome back. Welcome back. I'm going to get even closer to the mic. I heard it was a little bit far in the first half. So again, welcome back. I promise the second half is as exciting, if not more. What I really hope to take away from your engagement here is this is truly just an invitation, right? So ultimately what we're doing today is inviting the community to engage. If there was something you heard in the first half, something you hear in the second half, the answer is yes, come engage. All right, so with that, I'm just going to acknowledge one amazing program that we've been working for many years, starting from the Competition Institute all the way through for the Center of Data and Computing, and now at DSI, which is our Summer Lab program. I just get to be lucky enough to stand in front of all those amazing students. That was last year's cohort. This is a program over the summer that engages students from high school, undergrad and master's students in data science. And so we have incredible research going on with faculty, projects at the intersection of research and social impact. And we're just thrilled to be inviting our first class back in person this summer, knock on wood, if I knock on the microphone. And so we are really excited to bring that energy back into the university and have all these students sort of engage all summer. And so with that, though, I would like to turn directly to our next research initiative, which is our AI and Science Research Initiative. And so I'd like to bring back to stage Rebecca Willett, our DSI Faculty Director of AI, and introduce as well for the first time Juan DePablo, who is the Executive Vice President for Science Innovation National Labs and Global Initiatives at the University of Chicago. That's a big portfolio. He's also the Liu Family Professor in Molecular Engineering and a Senior Scientist at Argonne National Laboratory. His research focuses on developing new material widely used in many fields of engineering, using molecular models and computer simulations of complex molecular processes. Joining Juan is Aaron Dinner, is a professor of chemistry and deputy dean of the Physical Science Division at the University of Chicago, and a dean I got the pleasure of working with mostly remotely, and I met for the first time today. Dinner also holds appointments in the James Franck Institute and the Institute for Biophysical Dynamics. He uses machine learning methods to model complex cellular and molecular processes with significance in medicine and health. Please join our AI and science research panel on stage and welcome them.
Well, thank you very much, and thank you for organizing this amazing inaugural workshop, the first of many, I hope. So we've heard throughout the day that impact is important, that data science is a global endeavor, and that changing the way we do science is very important. I see it at the intersection of all of those questions. First of all, innovation. I think we need to find ways of translating our discoveries into startup companies, not-for-profit organizations that really let these discoveries have the impact that they deserve. Second, we are a global university. Data science is a global endeavor with 5 centers throughout the world and a network of students with over 200,000 members. You think that we ought to be able to do something interesting with all of that in the context of data science. And perhaps most relevant to our conversation in a moment is the fact that the University of Chicago manages and operates 2 of the great national laboratories of this country, Argonne and Fermilab. These are laboratories that are home to some of the great high-energy physicists, astrophysicists, mathematicians, computer scientists, material scientists, chemists, all of them using AI for science. And of course, it is home to the soon-to-be fastest computer on the planet. And I'm looking at Paul Kearns, who's the director of Argonne. So with all of that, I think that it is interesting now to have this conversation on AI for science with Becca and Aaron. For starters, Becca, so what is AI plus Science Initiative? And then why are we doing that now? Why is now the time to do that?
Great, thanks very much, Juan, and thank you so much for all of your support for this over the years. Our main claim is this: modern artificial intelligence and machine learning are going to fundamentally change scientific discovery. So collecting and analyzing data has always been at the heart of the scientific method, as I'm sure you're well aware and many people in this room know. But now we've got a new opportunity to make AI an integral component of the scientific method, guiding the construction of new hypotheses, designing sequences of experiments, and analyzing the data that we collect to develop new theories, all while developing the foundations of AI. So off-the-shelf machine learning and AI tools are insufficient for this task. We really need to develop a new field of AI in science to catalyze this process of AI-enabled scientific discovery. It's only by using powerful machines coupled with sophisticated algorithms with domain-specific constraints that we're going to be able to advance this revolution. So within the Data Science Institute, we envision a new paradigm of transformational AI-enabled scientific discovery across the natural sciences, advancing the foundations of artificial intelligence, and training a whole new generation of diverse interdisciplinary scientists. And we're going to manifest this vision by forming cross-disciplinary teams and partnerships with the national labs and other research institutions around the world.
Very interesting. So, Aaron, you're using AI in your own research in chemistry. Can you tell us about how you do that? And then how these new collaborations that the DSI might foster influence your work, and importantly, how they might change the foundations of AI.
Sure, Juan. Yeah, so much of my research involves large-scale simulation of high-fidelity models of biological molecules, and AI can help us in 2 ways with those. They can accelerate the simulations to bridge separations in timescale between bond vibrations and functionally important motions, and they can help us interpret these very complex models. Recently, we've been working with applied mathematicians, including Yuhua Ku and Mary Silber here in statistics. What that's let us do is marry a rigorous statistical mechanical framework with AI to be able to aggregate information from many short simulations, and then to forecast long-time molecular behaviors, and in turn to do a kind of domain-specific dimensional reduction and feature selection to identify what's important for those long-time behaviors. Short other example is that we've been working with Mike Rust in molecular genetics and cell biology and physics to directly learn biological regulatory networks from data. And in that case, the loss function is actually quite computationally costly to evaluate because you have to simulate the fluctuations in molecular concentrations. And so we're hoping to work with researchers in DSI to dramatically accelerate those simulations because by exploiting surrogate models and normalizing flows.
So, Becca, what are UChicago's efforts in AI for Science distinctive? Why are we special, if at all?
Yeah, no, it's a great question. So I think one key distinctive feature is our focus on foundations. So we're not viewing AI as just one more tool that we can apply to scientific data. And we're not thinking of the natural sciences as just one more generic way of generating data sets for AI. But rather we're seeing it as an entirely new and integrated field with a totally disruptive approach to discovery and technological innovation and impact, all at the forefront of research. So with this in mind, when we set up this AI and Science initiative, we didn't organize it around traditional disciplinary boundaries, but instead we crafted 4 key themes that hopefully are going to catalyze a lot of interactions that have previously been missing. So the first of these themes is AI-enabled scientific inquiry for discovering new fundamental principles. And this is something that I know you have worked in, Juan. Another example of efforts on campus in this space are by physicists Vincenzo Vitelli and Margaret Gardell. So what they're doing is they are trying to take observations of cells in a culture as they interact with one another and trying to understand what are the fundamental governing laws, the equations of forces and motions that are controlling the way that these cells interact with one another. So they're not trying to observe it and then reproduce the behavior, but they're trying to come up with new mathematical descriptors and new theories of biophysics. And what they've uncovered so far is totally upending previous biophysics models. Our second theme within the AI and Science initiative is physics-informed machine learning. And there's a lot of activity on this on campus. So in particular, Aaron and I have 2 co-leads for the AI and Science initiative, Rishi Kondor of Computer Science and Statistics and David Miller of Physics. And they've been working together to design entirely new neural network architectures that from the beginning are designed to represent fundamental symmetries in the standard model of particle physics, namely Lorentz symmetry. And so they were able to use these new architectures of neural networks that were inspired and guided by our knowledge of the natural sciences to study particle collisions at the Large Hadron Collider and show that it worked. Other examples include work in my own group where we're trying to combine models of the climate together with huge collections of observational data to make faster simulations and better forecasts, and work being done in the medical school. So for instance, Xiaochuan Pan and Emil Sidsky in radiology are looking at ways to use physical models of MRI and CT scanners collected or in tangent in combination with training data to improve the speed and quality of medical image reconstruction.
I can speak to our other 2 themes. So the third theme is about AI guiding scientific measurement. And AI really has the potential to transform how we do experiments and even simulations. So for instance, a particle accelerator, it collects much more information than can possibly be kept. And so researchers are forced to throw most of that information away using fast but inaccurate heuristics. AI can enable us to do accurate, rapid, real-time filtering. In fact, actually, David Miller, who Becca mentioned just a moment ago, he has a separate project with Yusin Chen in computer science to do exactly that. What they're trying to do is autonomously curate the flood of data coming from the Large Hadron Collider. And one interesting thing about that project is that actually the same approach can then be immediately carried to other fields for, say, a large sky survey in astronomy or a driverless car project. And that really highlights, in some sense, the strength of an institute, as you can take advances in one area and very quickly cross-pollinate them to other areas. To give just one other example from simulation in that regard, the same algorithms that Andy Ferguson in PME is using to guide the search of molecular design spaces, Seppi Kuhn in ecology and evolution is able to use to think about the composition of microbial communities that he's trying to make.
Yeah, so usefulness all over the place.
Oh,
the theme of the...
Actually, I guess I didn't get the fourth theme in there, I'm sorry.
Really all over the place.
Yeah, the fourth theme is scientific discovery driving foundations of AI. And so really, just in the examples that I already told you, you see that you have domain-specific problems, and they're actually driving new AI theory, methods, and open source software, and that can then solve problems that cut across the disciplines.
So we have very little time left, but in the spirit of getting everybody involved and inviting them to join you, can you tell us about some of the activities that are currently underway at the AI for Science initiative?
Yeah, so let me just mention three of them, Juan. So we've organized a summer school for the week of August 8th. We have experts coming from all over the country to lecture. We had originally expected 50 participants, but we've actually had overwhelming interest, and so we're working to accommodate more than 3 times that number. The second thing is we have a limited number of postdoc fellowships, and more than just providing support, together with some other recent initiatives in the physical sciences division, those are building a cohort of similarly bright, young, energetic, interdisciplinary scientists. And then the last thing that I wanted to mention is that we actually have an open call right now for proposals to initiate new collaborations between University of Chicago, Toyota Technological Institute, and the Weizmann Institute of Science. And that program provides up to $500K over 2 years in 2 areas, AI plus health and biology and AI plus materials science.
All right, so send in your proposals. Thank you very much.
I'm really sorry, but there was one other point I wanted to make that I think you'd be interested in too, Juan, which is a lot of this is enabled by our partnerships with the national labs, with Argonne National Lab, Fermi National Accelerator, the Marine Biology Lab, and Toyota Technological Institute at Chicago. And so I think, you know, within this ecosystem, we've really got an amazing critical mass that's unmatched, I think, anywhere in the country, and makes this especially exciting.
That was the most important point, so thank you.
And also, isn't there a social event, an AI plus science social coming up?
Yeah, that's right. That'll be next Thursday, or this Thursday, excuse me, this Thursday at, it's on our website.
And it's open to whoever wants to, yeah, great. Okay, well, thanks very much. So continuing on our different paths of engagement. So next thing we're going to talk about is industry partnerships. So data science is inherently a practical discipline. Its roots and many of its key advances began in industry, and a high bandwidth dialogue between researchers and practitioners is crucial to its further development. Many of us in leadership roles in the DSI come from research backgrounds where we successfully worked with leading companies, and in some cases, we even started our own. These collaborations inspired our students, providing them with use cases, data, mentorship, and more, while the companies were able to enhance their own innovation cultures by engaging with the long-term foundational thinking that thrives best in the university environment. So for these reasons, A founding principle of the DSI has been to actively engage with industry by cultivating and expanding relationships with industry partners and by pursuing real-world impact through entrepreneurship and other translational activities. Data science and artificial intelligence already play critical roles in the current wave of entrepreneurship. A recent study released by Silicon Valley Bank and AngelList ranked Chicago as its most active emerging tech hub, with 132 venture-ready startups formed in 2021, 12 unicorns minted in that same year, and a huge increase in the amount of venture funding available in the city. The University of Chicago plays an important role in this ecosystem through the Polsky Center for Entrepreneurship and Innovation and through related programs. DSI is working closely with the Polsky Center on new programs for UChicago faculty, students, and staff to translate their research into promising new startups. And this fall, the DSI and Polsky will launch a new accelerator for early-stage science companies based on a successful model that the Polsky Center has deployed for other science and technology areas. In addition, DSI has created a new industry affiliates program to anchor collaborations with larger established companies. Focusing first on companies with a major presence in the Chicago area and the Midwest, we plan to extend this program more broadly, nationally, and beyond. And today, I'm pleased to announce the initial founding members of our industry affiliates program: Prudential, American Family Insurance, Verizon, and DRW. I believe we have people here from all of those partners. Yeah, I think that's worth mentioning. These companies are actively collaborating with DSI faculty, students, and staff on research projects to expand the capabilities and applicability of data science, and on clinic projects that enable our students to gain real-world science experience while tackling data problems that are of great importance to our partners' businesses. If you're interested, here's the advertisement. If you're interested in learning more about our industry affiliate program, don't hesitate to reach out to me or any of my DSI colleagues. Okay, so joining us next is one of our founding partners, Prudential, who've been actively engaged with DSI since the very first quarter of our data science clinic. David Uminski is going to moderate this next panel. And joining David are Kristen Moody, who is the Chief Data Officer at Prudential Financial. She's responsible for enterprise data strategy, data management and governance, data and modeling platforms, master data management, analytics, and emerging technologies. She has more than 20 years of experience working with business teams and leaders to effectively use this technology, data, and analytics to improve or transform businesses. She has previously worked at State Farm, Unilever, Thomson Reuters, and she received her BA in economics from UChicago. Joining Kristen is Alex Hayward, who's a fourth-year undergraduate student at the University of Chicago studying data science with a specialization in engineering. She has served as a data science fellow for the National Institutes of Health and has worked on research projects with UChicago Medicine and the Pritzker School of Molecular Engineering. Finally, they are joined by Ethan Kroituru, who's also a fourth-year undergraduate student at the University of Chicago, studying computational and applied math. Ethan will be continuing his data science journey after graduation at JP Morgan Chase. So thank you very much, and take it away.
Thank you so much. I am so delighted to see these two students actually in person again. I was, among many things I did last year, I was very fortunate to be able to mentor the very first clinic with Prudential, and we're going to talk a lot about that today. But joining us as well is Kirsten Moody, who really spearheaded our first partnership here at the University of Chicago. And so I just am going to start with you, Kirsten. What attracted you to Data Science Institutional Partnership? And can you tell us why the Ethical AI Project, which was the center of the students' work this year, was important to Prudential?
Well, I'll pick up on the themes that we've heard about this afternoon. It was really the multidisciplinary approach that the University of Chicago was taking to the instruction, to the research, to the philosophy, really, within data science. We looked at a number of different institutions to potentially partner with, and the University of Chicago really stood out as being, at its core, a multidisciplinary approach to the topic. And then, ethical AI, responsible uses of AI was the topic where we had our first program with you. And we are sort of within the company really pushing ourselves to think in leading ways about the deployment of AI solutions in the business. And we recognize that for that deployment to be successful, we need to be co-creating kind of the governance, the observation, the transparency of our uses of an AI. So as we rewrite the rules using AI in the business, we also need to evolve those same rules in terms of how we keep the business safe, sort of hand on heart, operating the way that we would want it to. And when you put sort of that intent with ethical AI together with the multidisciplinary approach the University of Chicago is taking, it was really sort of an easy pick, actually, in retrospect.
Thank you. And Ethan, I have to ask you first. You enrolled in Data Science Clinic. It was the first time that course was offered to undergraduate students, so thank you for your bravery. What about the choice of projects drew you in particular this one, and did it meet your expectations on working on it?
Yeah, so I think the first thing was that I wanted to avoid faculty research projects, was because prior to this, I did 2 years of faculty research under a PI, so I wanted to expand to civic tech or with industry, so that sort of narrowed my choices first. And then I also wanted to apply a lot of the theoretical knowledge we gained in our courses here at the university. So I wanted to sort of choose the project that seemed the most challenging and was sort of model heavy, because a lot of the civic tech projects were a lot of data engineering and pipeline building projects. So Prudential offered a lot of natural language processing questions in terms of using a wide variety of data sources to analyze that. And they really did keep up on their promise for that, as I'm sure both of you remember. We had to utilize and implement a wider range of NLP techniques, from sentiment analysis to topic classification and so on. And yeah, it was, and I would also, as someone who wants to start a career in data science, I would really be remiss to pass on the opportunity to work underneath Prudential data scientists and everything, as it was truly their feedback and their input that contributed to what I would consider my most influential course here at the university.
Oh, thank you, Ethan. And then a shout out to Amal and Robert there, that were really working quite hard with the students. Our mentors on the industrial or our external partnership side are really critical. Well, Alex, I get to turn to you, who I'm very proud to say, is one of our first declared majors in data science. So I have to ask you, in your senior year, what drove you to declare the data science major, and how did the experience working on such a real problem, have an impact?
Definitely. So during my undergraduate career, I engaged in a few research projects where I was performing experiments and data analysis that got me really curious about data science. So I decided to pursue the minor, and by the time I became a senior, when they offered the major, I knew that if I really was going to commit to pursuing data science, that I wanted to gain as much skill building and hands-on experience as possible, and that's exactly what the data science major offers, particularly the data science clinic. Working on a real-world project is nothing like class. You're not given a clean toy data set or a Jupyter notebook to fill out. We were tasked with retrieving, cleaning, and labeling our own data, which really required getting into the weeds of the data and understanding whether that data was appropriate for the question we were trying to ask. And along those lines, I think that the real-world project experience taught us the importance of being able to define and articulate your research question, the client need, our limitations, and always staying humble about those, as well as meeting frequently with Prudential. We had the privilege to meet with them once to twice a week and gain their constant feedback. We learned how to integrate client feedback in a timely manner, as well as how to communicate not only that research question, but also your work and its impact to a diverse set of stakeholders in an accessible way. I also learned so much from Ethan throughout the course of the project, and I would say that week to week we had to wear a lot of different hats, from engineering data pipelines to evaluating state-of-the-art NLP models, and I think that being able to work in an agile environment with a partner really allowed us to share our perspectives and bring our skills to the table, as well as learn from each other in the areas that we had less experience in. Particularly with Prudential, I think not only did we have the opportunity to explore ethical AI through literature review and research, but also implement it in practice in designing our tool to have explainability, responsibility, and fairness principles by design. And so I think that the data science clinic was definitely one of the most formative parts of my data science education and has definitely prepared me for the field. Thanks.
Thank you, Alex. Tristan, I have to ask, and there are a lot of students in the room and certainly online as well. You're the Chief Data Officer at Prudential, so we're going to take advantage of an alum of the college. And what advice would you give students, and maybe you can extend that advice to faculty, around in career in data science?
I don't know that I would be so bold as to extend advice to the people who probably taught me. I think some of you might be out there. So I think really take to heart, cherish, and nourish over your career the value of the foundations of the liberal arts education that you have here. We have heard over and over today how data science is a multidisciplinary topic that is going to be integral to solving many of the big problems that we as societies, as humans, are facing over the foreseeable indefinite future. And it's not the mathematical skills, it's not the computational skills that will take a practitioner of data science to the leading edge of that field. It's the interdisciplinary approach and the understanding, the ability to ask questions, the ability to understand from multiple perspectives. I'm looking for people who have studied Hobbes and Rousseau and went through that in the early days, in addition to having a world-class sort of data science-focused, mathematically, computationally focused curriculum. It is the diversity of thought that really matters, and we are actively seeking talent that is hungry for that. So keep it up, really.
Well, I really want to thank both our students that had both the confidence and extraordinary success to really be a shining light to what the clinic really means for the university and the way we think about experiential learning. It is capital E there, I would say, at least in this particular group. And I really want to thank you as well, Kirsten, for the trust and taking the leap with us in this new partnership, and excited about all the things to come.
Absolutely. It's truly been our pleasure. Thank you.
Right, thank you.
There is a lot to tweet about after this panel, so I hope you took notes and you're tweeting. So many of our students gravitate towards the social impact projects in the clinic, and we partner with the 11th Hour Project of the Schmidt Family Foundation, an organization with more than 400 grantees across the globe, focused in 4 main impact areas: energy, food and agriculture, human rights, and marine technology, to provide a wealth of social impact data science learning opportunities. Our students and researchers work with 11th Hour Project nonprofits as a centralized hub of software and data science support. To talk about one such project with Inclusive Development International, here is Daniel Grisenta, who's a staff data scientist supporting the partnership with the 11th Hour Project at university. He engages with social impact organizations across all 4 domains to support applications of data and computer science. Lona Greer, who's a software engineer responsible for executing data science clinic projects with student teams in conjunction with the 11th Hour Project, as well as internal projects for the DSI. And Mindy Mislevic, we all met, who is the Senior Director of Outreach and Chief of Staff for the Data Science Institute, managing, sourcing, and scoping a portfolio of data science experiential learning partnership across social impact organizations, corporate, civic, and government entities. Mindy is moderating.
So Daniel, can you start off and tell us how the Data Science Institute works with the 11th Hour and how those projects feed into the clinic?
Sure. Thanks, Mindy. Our work with the 11th Hour has been a part of the DSI really since we began, almost 2 years ago, when the DSI was just in planning. DEBIT, the project you'll hear more about today, was one of the first projects we started. And so I'd say our work really has, with the 11th hour, has been a key part of the outreach pillar of the DSI. And the idea behind the outreach pillar, right, is that you don't need to be a large corporation with lots of data scientists or huge data sets to really make use of these tools, but that you can find plenty of interesting problems and data sets working with our partners in the nonprofit space, as well as social impact organizations. So it was really this early work with the nonprofits that got the data science clinic started. So I think you heard many times today from David that the work we do doesn't just fall in one pillar, but is usually spread out between many. And so the data science clinic is an experiential class that the last panel told you all about. We pair students in teams of 3 to 5, match them with a mentor and an external client, and really support them as they get their hands dirty in a real-world data set. So these nonprofits have been great partners, allowing us to work with these organizations, allowing us to work with their data, giving us insight into how they work with these tools. And it's really been a win-win because many of these nonprofits also lack time, funding, or resources to get the most out of data science. So through this, we hope the Data Science Clinic and the funding from the 11th hour, we hope to serve as a hub for these nonprofits and to keep providing software and data science solutions so that they can advance their missions.
Thanks, Daniel. So Dustin Rosa, the Executive Director for Inclusive Development International, was going to join us today, but due to an illness couldn't make it. So on behalf of Dustin, I'd like to go over a bit about IDI. They're a human rights organization based in the US. They support people around the world who have their rights impacted by projects like dams, mines, or plantations. For example, you might be a farmer living in Indonesia, and a large mining company has moved in and taken your land and demolished your house. You don't get to negotiate, you don't get to seek compensation, and your life is now much worse off. That's where IDI created the Follow the Money initiative. That community in Indonesia can come to them and request their research support. They uncover the hidden web of investors, lenders, and buyers that are funding these projects. They open this now, the Follow the Money initiative opens up new opportunities for people to defend their rights. For instance, if one of the funders of that Indonesian mine is a development bank with a strong human rights policy and a watchdog office, people can file official complaints. Finding those development banks can change the game for communities on the ground with few good options. But these development banks are hidden and difficult to find. So the researchers of the Data Science Institute and IDI worked together to develop a tool called the Development Bank Investment Tracker, or DEBIT for short. This makes the research faster and far more accurate. DEBIT expands the research capacity of IDI's small team. They can now support more communities who've had their rights violated, and they can better hold development banks accountable for harmful investments. So Lana, can you tell us some of the challenges with creating this tool?
Sure thing, Mindy. University students first began working on the DEBIT project for a winter 2021 data clinic class. Their first task was to cross-reference 17 different development bank websites to create a general model of what a project looked like. Afterwards, they built tools to scrape data from those websites. While iterating on the design of these tools, we really faced 3 main challenges: efficiency, web page updates, and increasing the transparency of the effects of these projects on local communities. In terms of efficiency, we discovered that crawling through search results pages to fetch individual project pages was a time-consuming process, especially for large sites that had tens of thousands of records. To address this, we scaled our web request within the cloud and are now able to collect around 300,000 records in a matter of hours. In regards to web page updates, we found that our scrapers broke, not surprisingly, whenever banks updated the format of their web pages. To address this problem, we recorded the results of each scrape page in a database to track errors and allow for retries of failed pages. This allowed investigators to have a complete list of projects. And finally, to boost the transparency of the effect of these projects on local communities, we received a list of complaints from one of our 11th hour partners, Accountability Council, and then used classical natural language processing to merge the complaints with the project records we had scraped based on the similarity of their project and country names.
What do you anticipate will be some of the main achievements of DEBIT?
I really believe DEBIT's achieved its mission of providing greater transparency to the world of development finance. It's evolved to become a flexible, scalable, cloud-based pipeline that aggregates, cleans, and serves development project data for the public. We're really excited by the fact that DEBIT scrapers are open source, so any member of the community can now write a new scraper for a new financial institution or repair scrapers that have broken. We look forward to continuing to improve and grow our tool, and in the future, we hope to incorporate private banks.
So just this past month, Dustin was able to launch DEBIT officially with a number of researchers in Africa. As part of the Follow Money initiative, which they started 6 years ago, they've already investigated 200 harmful projects. This has opened up hundreds of new opportunities for people to defend their rights. They've used their research to stop risky projects before they happen, or to secure redress like land or financial compensation for many of these communities who have suffered. Although IDI's research team is very small, and they can't help everyone to meet the demand, and that's part of where the Follow the Money Research Initiative and the tools like DEBIT come in. So DEBIT and the other tools that we're working on with the DSI are central to this vision. Ultimately, IDI wants to create an open source, open access financial terminal for human rights defenders, much like a Bloomberg terminal. So IDI launched Follow the Money training in Kenya. I already told you that because I skipped around on the slide and trying to rush. So either way, we're excited about this opportunity and how we can expand their research and ours. And Daniel, can you tell me a bit about some of the other projects outside of IDI that 11th Hour's worked with in the Data Science Institute?
Yeah, so over the last 2 years, we've worked with a variety of nonprofits. You should see some of them behind me. We've had the opportunity to work with almost 30 different organizations. These nonprofits span the areas of energy, food and agriculture, human rights, and marine technology. And as you can imagine, these nonprofits each have very different data sets. They're in different stages of the data science life cycle. They have different resources and different problems to solve. And working with so many groups has given us really insight into the types of problems that each of these nonprofits face across different domains, across these different stages of data science. And when we see these solutions that span multiple organizations, we get pretty excited. I think DEBIT is a good example of that. You heard earlier from Lana that we had collaboration with Accountability Council, who works kind of on the community side of the development pipeline, as well as IDI, which is on the financial side. And so when we can bring these two grantees together and collaborate through data, that's the best part of this job. And so in the next couple of months, we're hoping to release a few more tools, solving similar problems for other domains, and really begin to build a community of nonprofits around data science.
Thank you both so much.
Okay, we have one more panel. This panel focuses on the newest of the DSI research initiatives, launched with an initial round of seed projects just 2 months ago. The Data and Democracy Initiative is a collaboration between the DSI and the Center for Effective Government at the Harris School of Public Policy. Its mission is to ignite interdisciplinary research on the digital challenges facing democracies around the world. Our panel includes DSI Faculty Director Nick Feemster, who you've met before. He's going to be joined by Kate Baker, who's the Dean and the Emmett Dedman Professor at the University of Chicago Harris School of Public Policy. A leading scholar in the economic analysis of health policy, Baker's research focuses on the effectiveness of public and private health insurance, including the effect of reforms on the distribution and quality of care. Dean Baker has been a key partner in the development of data science on campus, and we really appreciate all her help in that regard. Joining Kate and Nick is Bill Howell, who's the Sidney Stein Professor, Will Howell, the Sidney Stein Professor in American Politics at the University of Chicago, also chair of the Department of Political Science and the director of the Center for Effective Government. He is also co-director of the DSI Data and Democracy Initiative with Nick, and we're going to hear about that now. So please welcome this panel.
How about now? total victory. I'm going to keep my introductory remarks to a minimum because these guys have about 15 minutes to explain to us how they are saving democracy from the digital doom that I feel looming over us every day. But it's all going to be okay because we now have leading experts in democratic government and effective government and wrangling the digital resources and threats that are available to try to think how we can join forces to move towards a more effective government in a digital world. And so I'm going to start by turning to Will and saying, you have deep expertise both in yourself and in your center on what makes governments effective versus not effective. But the world of misinformation and disinformation is really changing how we learn about what's working and how we think about better institutional design. How are you hoping to draw on the resources that are available across the field and across the university to enhance the direction of that line of endeavor at the University of Chicago?
Boy, there's a lot in play, isn't there? My parents called me Bill. We'll talk.
I
And I love my
makes
parents.
it better or worse.
So look, democracy's in trouble. It's on its heels in a lot of places, very much including here at home. At the Center for Effective Government, we think a lot about issues involving institutional design, how to build a government that's capable of solving problems, meeting the needs and wants of people. And when you think about the threats to an effective government, they're not just about the failures of design. They also have to do with disenchantment with government, distrust in government. We need to be thinking about the changes in the media environment, the demise of local news, to think anew about where people are getting information and how they put that information to use, both in formulating their own policy views and how they organize with one another, how they engage politics broadly. And this is a big space wherein, frankly, we need help. And we need help from people who have been thinking long and hard about this digital environment, how to measure it, how to characterize it. I think we have a lot to say in terms of the collaboration, in terms of where to train the telescope, but and what kinds of questions to ask. But this is a collaboration that is just ripe for the taking. I mean, this is low-hanging fruit, and I'm really delighted we're getting this going.
Speaking of people who have been thinking long and hard about the tools that we have available, the distribution of those resources, and how they can inform better policy, Nick, I want to turn to you. It seems like there's a little bit of a tension between thinking about government as part of the solution to better translating resources to improving lives, and government as part of the problem in disseminating bad information or the use of the digital architecture to achieve ends that are maybe not what we would be hoping for. How do you think about the right role of government and policy, and how does the work of the collaboration hope to inform that?
Yeah, I think this is an interesting pairing, because when I learned about Will's Center for Effective Government, I thought, that's interesting. That assumes that government is part of the solution, right? And I think, as I mentioned earlier, having done a lot of work in internet measurement, we've been doing a lot of work on internet censorship for quite some time. And so I've always come from the perspective of foreign governments really as the oppressors. Certainly I think there's been a lot of study, and I think this is very interesting. I think in Will's domain discipline, China in particular as, shall we say, an innovator in the use of technology to oppress human rights. And I think a lot of that work has come out of political science, in fact. And I think it's certainly, now we thought we'd never see those types of techniques in Western democracies, but we're seeing, the abuse of all kinds of platforms, from just regular internet access to social media, to online chat, to do everything from suppress the media, to disrupt political protests, to affect elections. And so I think it's a pretty interesting space, because I don't know if you would agree, Will, but I think at least from my perspective, and I think certainly historically we've sort of seen the Western democracies, functioning a certain way, and other countries, shall we say, operating in a completely different way. And I think now we're seeing with the technology that blurring a little bit more than I ever thought we'd see it.
That's for sure true. And the technology itself, we can see how it can at once advance democratic, small d democratic claims and also impede them. There are some ways of organizing from the ground up in the name of social movements that are facilitated with this technology, these technologies. And so one of the phenomena that's of interest that would be worth exploring is to think about how that online communication works and how it translates into offline behavior, which we might think of as being democracy enhancing, just as you can, you've just pointed to a number of examples where autocratic regimes use the technology not to expand rights or to expand the franchise, but rather to suppress them.
So how do you think of the unique opportunity here at the University of Chicago and with the Data Science Institute to really harness those tools for good? When lots of people think about use of data in public discourse, and lots of people worry about democracy, but we have a unique intersection here. Can you give me some examples of how we're using it?
So I'm thinking back, David, to our conversation in my backyard when we had beer and there was meat that was grilling, and we were talking about, this was just an idea at that point. And an early commitment was the idea that this should be joint from the ground up, that this needed to be an instance not where folks in the digital space, the computer scientists, are going to get way out in front and excited about a set of things and then bring in a political scientist to tell a story on the back end to sort of illustrate something. Nor would it be an instance where political scientists would sort of overclaim without being grounded in a set of clear insights about what's actually happening out in the world. And so I think that's and that this is what this university does so well, right? I mean, this is about bridging those divisions across disciplines in a serious way. And the other people who are, the other sort of centers that are working in this space, it's usually one community or the other constitutes an afterthought.
I think there's a really interesting intersection between the technology and the policy here, and I think some of the other researchers who are working in this initiative, in particular in Will's department, Molly Offer-Westor, is doing some really interesting work looking at how chatbots affect people's opinions on various matters of policy. And I think there's a wide variety of policy initiatives where someone's opinion or perspective, or where they get their news, or where they get their perception, will ultimately affect what they do. Do they go get vaccinated? Do they show up to the polls? Do they sign up for an internet subsidy program? Those all depend on how someone perceives that program, how they perceive the role of government. And so when you talk about Center for Effective Government and how does a government be effective, ultimately those channels of how people perceive what's going on, that's a question that really intersects internet technologies, platforms, and policy.
So I might have thought to ask the question, are we better or worse off in terms of democracy and governance because of the new technology that's available? But in some ways that doesn't matter because the technology is here, and the answer can't be, we're just going to stop using Twitter. Everybody just stop. Even though that might be a nice answer, it's not really feasible. How do you see where do you see the greatest promise in using technology in a way that is likely to promote better government, better use of resources, more transparency, and what are the infrastructure, what are the governance structures that you think need in place from a public policy perspective to push us in that direction? That's for both of you, because we don't have much time for you to fix everything.
Yeah, and I guess in the next 2 minutes we'll try to fix it. But I think I think as you mentioned, these platforms are here to stay, and I think one of the questions you raised, and I'll leave the harder parts of the question to Will, but I think one of the questions you raised was governance and sort of the role of, let's say, data science and what can our role be here. And I think there's a really interesting intersection there in the traditions of this university, right, in the tradition of free expression, right? And I think a lot of what we see on these platforms is a tension between freedom of expression and effective functioning in society, effective governments, and so forth. And I think one of the things that we're seeing, in policy and law and so forth, is an attempt to regulate the platforms. And that intersects in a really interesting way with technology, right? If you look at like the Digital Services Act in the EU, if you look at what's going on with Section 230 in the United States, there are basically requests or requirements for a platform to take down all of a certain type of speech. Well, I don't know who's writing these laws, but they are apparently not very well versed in how much content is being created. And that immediately implies an algorithm, like some level of automation in some stage of that process. And I think what we heard from our student and industry panel earlier about engaging in that process and figuring out, well, what can the data tell us? What can't it tell us? What are the limitations? I think we've got a lot of work to do there, but I think there's a huge promise, huge opportunity for those of us at this university working at that intersection to contribute meaningfully to that discussion.
This is a vast space. One piece, I guess, I think I would add just now is that questions aren't just what's being said and for what purpose, but also who gets to say, whose voices are heard, whose voices are centered. And I think one of the things that's happening, it's both a promise and in some ways it depends on, it's all contextually defined. But Kathy Cohen, who gave the Ryerson lecture last week, was thinking a lot about what it means to center the voices of people who are traditionally marginalized. And when she wants us, she encourages us to rethink democracy. She's also encouraging us to think anew about digital democracy and those sorts of spaces where increasingly we hear from the voices of people who are young and marginalized. And that to say that democracy is on its heels is not to say that it was ever perfect. There are deep, long-standing inequalities. And so that, too, constitutes an important space for inquiry and investigation.
This is all a really exciting set of opportunities, and of course you're not people who wait for official launches to get going. So maybe for a last question, can you tell me about a seed project either that you're working on or that somebody else has been funded to do that you're really excited about?
So I mentioned Molly's project already. So that is one of the seed projects that's funded out of the program. I think another one that I alluded to actually is one by Chen Hao Tan and Marshani Chetty, who are also looking at content moderation platforms online, right? So if you look at basically all of these platforms, and by the way, we think of Twitter, Facebook, and so on, but did you know that Etsy has a content moderation policy, right? Because the stuff that gets sold on there has everything from copyright violation to hate speech to disinformation.
It's not just kitten t-shirts?
Apparently not. I mean, you know, I can get you a mug with anything you want on it, I suppose. But you know, figuring out basically how people perceive, how they understand those policies, what the effects are when content is moderate, how do people react, right? Do they go away or do they come back emboldened? All those types of questions, I think, are wide open, and I think that project on content moderation is a really interesting angle.
One feature of contemporary American politics is the rise of populism that expresses itself in lots of ways, not least of which is rhetorically. There are all kinds of people attacking other kinds of people in an effort to delegitimize government and in order to paint the opposition as extreme. There's one of the projects is exploring how kind of the institutional origins of those phenomenon and to think anew about how we might measure disagreement and the extent to which in the context of campaigns, people holler at each other. This is something that political scientists have been interested in a very long time, but we've done a very poor job of actually measuring, which is why it's exciting to be pairing. Yet another reason why it's exciting to be pairing with the scientists.
Not a seed project, but I'll interject. I think Will and I at some point had lunch, and I think one of the, we come from very, you know, disparate ends of the research spectrum, I think it's fair to say. But he posed this question at lunch, which I think captures it really well, some of the challenges, which is, we were talking about January 6th, right? Or any political event for that matter. And someone wants to know, where did that come from? Where did that offline action originate, right? And presumably, we know some of that originated online. But we can't see it. We can't trace the provenance of that messaging, of that data. And I think there's a huge internet monitoring question there, because we can't go back in time and get it. And you said earlier about focusing the lens, right? And I think basically there's a tremendously interesting question there, because we can't measure it all. How do we cope with scale to answer a question like that?
Well, clearly great things happen when interesting people have lunch. And I'm really excited about the work that you're all doing and thrilled to have the chance to share a little bit with you all and looking forward to the rest of the evening. Thank you.
Okay, so this is so exciting. It's, I think we all want to hear more of every single panel, and that's exactly what we were hoping to do, make everybody very excited to continue this conversation. And it's my great pleasure to introduce President Paul Alivisatos to share some of his thoughts on this topic today. He's the 14th president of the University of Chicago, and he is a distinguished and celebrated chemist and administrator and entrepreneur. He's also the John MacArthur Distinguished Service Professor in the Department of Chemistry, the Pritzker School of Molecular Engineering and the college. He previously served as Executive Vice Chancellor and Provost of the University of California, Berkeley, where he was the Sensing Distinguished Professor of Nanoscience and Nanotechnology, founding director of Calvi Energy Nanoscience Institute, and director of the Lawrence Berkeley Labs, among many other roles that he had at that institution. He's a preeminent scientist and entrepreneur, as I mentioned before, and he has pioneered in the fundamental physical chemistry of nanocrystals and nanomaterials. Some of his science has led into many applications in biomedicine and renewable energy, and his scientific advances have yielded more than 50 patents. Alivisatos has received, and we're very, very proud of that piece, his bachelor degree in chemistry from the University of Chicago. So welcome back, Paul. And he also got his PhD at Berkeley, which is where he decided to live for a little longer, but we'll fix that problem. He has been recognized by a very long list, and since we're running a little late, I'm just going to mention the National Medal of Science, and a membership at the National Academy of Sciences, the American Academy of Arts and Sciences, and the American Philosophical Society. So welcome, Paul, and thank you so much for sharing some of your vision with us tonight.
Thank you so much, Angela, and I want to thank all of you collectively for running a little late, because as a consequence, I got to see 3 of the panels just now. And it was astonishing to see our students and faculty and staff and the many others that we partner with, foundations and corporations and others, and to see what a beautiful integration is coming together around this topic. So I'm very grateful for that. I'd like especially today to congratulate Mike Franklin and Dan Nicolai, to thank you, Angela, and many others who have acted to support the early phases of what has now launched today as the Data Science Institute. It's taken a lot of years to get here, and it's involved many people from the university, but also many friends and donors and partners. So it's a wonderful moment, and it's a moment to contemplate things a little bit. And it's especially, to my mind, a moment to think of this as an inflection point for much more to happen in this field than has so far. So think of it as we've made some early investments in a seed phase, and now we're expecting a lot more to happen. And I'm thrilled about that, because I think many of you will have heard me speak previously about what I see as the importance of an engaged University of Chicago. And I see the Data Science Institute as being grounding and fundamental to achieving what that is. So let me speak a little bit to that. There are 3 things that I believe this university does exceptionally well. It has a tendency to like to create entirely new fields of knowledge. There's a long history of the university doing that, and we'll talk momentarily about how foundational data science is as a new field of knowledge, and how there's still a great deal more work to do to develop it further. My own experience as a student here was transformative, and I believe the university really specializes in trying to think very hard about how to create truly transformative educational experiences for students. And there's a third aspect of the university that I think is emerging and will become just a regular part of what we call an engaged University of Chicago, and that is to bring the whole university into partnerships that will bear on the hardest problems of society. And we saw a little bit of that just a moment ago. But I'd like to sort of show how I think some of those things can all come together in so many ways. As you know, the University of Chicago has a kind of culture of how it relates to knowledge. It's a very special culture. It's a place that really values and loves peeling back all the layers, really trying to understand things at the deepest level. Free expression is at the heart of it, because part of being able to do that is to really be able to be involved in some friendly disputation and really questioning things at the deepest level. It's also a place that is really deeply devoted to rigorous discussion, to quantitation, to understanding things at the deepest level that they can be. So those are all things which are just natural to this university, and they are so important to the fields of data science and these new methods of artificial intelligence and machine learning and so many other ideas that are growing at this moment. And yet, they are not yet completely foundationally understood. And there are so many ways in which we still need to grapple with their theoretical underpinnings as well as their conceptualization. So it's a growing field, but it's also one where there's just so much more to learn. Now, when we talk about that, I would also say another piece of it is to really, to be able to do that, to be able to create a new field of knowledge at the deepest level, requires the right people. And one of the ways in which I spent my fall, and as well as part of this term, since I've newly returned to the university, has just been to go around and visit every place. So I've been involved in a series of immersion days where I went and visited different parts of the university from breakfast through dinner, and I got to meet the students and the faculty and the staff and to walk the spaces and to see just what's happening. And so I had the most wonderful time getting to meet the faculty that are being recruited now. That the folks sitting in front of me have been involved in trying to bring here. And I was astonished by the talent level that I encountered. On one occasion, I got to meet Chen-Hao Tan, who was just mentioned a moment ago by Nick Feemster, human-centered machine learning at the intersection of human interaction, language systems, and decision-making. Now that is really important and hard work, and a lot to do there. Victor Veach, in that same presentation, got a chance to explain to me a little bit about designing trustworthy AI systems and what that would mean, adapting machine learning tools for learning causal effects. Talk about a really key piece of what we're trying to understand in data science, artificial and machine learning. It has to do with the ability to understand language or the ability to infer causal effects in some actually reliable way. Those are really hard problems. On that day, I didn't get to meet Claire Donat, but I've studied what she's doing a little bit, the analysis of patterns and the quantification of uncertainty in high-dimensional data sets, in particular graphs and networks geared towards biomedical applications. So actually, if we take that apart and we say, okay, we have a core faculty now that's really thinking about the hardest problems, and then we understand data science sits methodologically at a point that can intersect to almost every discipline. In my own research for about 5-6 years now, I've been trying to harness some of the tools of data science and artificial intelligence with my coworkers, and I can tell you, trying to get to the bottom of causal inference really feels like there's a lot of work to do. So that's important. That's important. It really is. Will data science, artificial machine learning, artificial intelligence, will those techniques really in medicine help us to lead to actual impacts that are benefiting patients? That's the work that Claire is undertaking here. That's at the heart of really understanding the foundations of these fields. The intersection with law, with democracy that we just talked about, and with so many areas. So I really think that this is at the core of what the university does. And to have this institute to bring people together to see the new methodologies, how they can branch out and touch other disciplines, it's just really, it is fundamental to what we want. I mentioned to you that the university should really be a place of transformative educational experiences. And I really enjoyed hearing Christian Moody from Prudential a moment ago talking about the importance of the liberal arts education connecting in with data science. One day, sometimes when I'm out and about, I go to dining halls frequently. I get to meet students. Just now, as I was walking over here, I got to meet a lot of students on the quad. Whenever I'm talking to them, I just try to understand, what are you studying? How are things going? Just a few days ago, I met a student who was studying double major in data science and philosophy. And I was saying, okay, what's the deal? What's going on? And he said, well, I'm really interested in epistemology. And this connection with data science, it just seems very troubling to me how this all works. I said, okay, this is great. This is just what we need. In fact, one of the things that's so interesting to me as I've returned to the university, when I was a student, hardly anybody was a double major. Actually, today, when we visit around the college, almost every student is a double major. And for a while, I've been trying to understand what's going on, what's the story behind this? And slowly, because I find very often it will be things like data science and philosophy or data science and linguistics and so on, or, and so on and so on. What I've really come to appreciate about how wonderful this generation of students is in terms of its way of grappling with knowledge and trying to find new ways to discover is the interconnection for them between something that they think is foundational and practical, that they can really use, with a topic about which they feel great passion. And so I think the data science education that's being created now, the new data science major and the other components of that, are part of a long-standing partnership between the different generations here at the university. It's our faculty working with our students to try to find the ways in which we can give them the tools that they need to attack the problems that they're really passionate about, but to do it with rigor and with the best ways of thinking and in really innovative ways. And I see that emerging beautifully in the areas of education, not just for undergraduates. There's enormous growth going on in the master's degrees that we are offering, which are helping people to go into the world and practice and to do things. It's impacting our doctoral students dramatically, and we'll see more and more in that. And indeed, in lifelong learning writ large, we're seeing that it's showing up in professional education and so many other areas. So it's truly at the level of education, it's showing up everywhere. For an engaged University of Chicago, we really do need to bring the whole university into a set of partnerships in order to address some of the hardest problems that we have in our world today. And this morning, when I scanned the newspaper, there was in the Sun-Times an article about Nick Feimster with Nicole Marwell, who had done the Internet Access Inclusivity Project. I happened to have seen it months ago when I visited in the fall, but to see it there getting play through the people of Chicago to understand that Internet access is truly not equitably distributed, as are so many other things not equitably distributed in our city, but to have a map that showed it, to show the differences, and to also have in there a sense that there is far more that they are going to be learning and discovering. To my mind, that ties very strongly around the topic of how this university has the capability and the desire to partner with community around us and with others, governments and foundations and corporates, to really be a part of an agenda of urban wealth creation in partnership with the community urban wealth creation. And part of that is going to be to use the data science tools to understand the problems and to see what can happen there. I also believe that the Data Science Institute is going to play an enormous role in the ability of this university to be a partner with societies globally around the issues of climate and energy. And the Climate Impact Lab today builds empirically founded estimates of the damages from climate change. Climate Vault researchers are using big data and machine learning tools to develop better estimates of emissions by companies. There's a whole framework of ESG that's being used right now. Is it grounded? Is it sensible? Will it work? Does it really make sense? We really need a place like the Data Science Institute to really help us to make that come to fruition. And finally, partnerships underpin all this work, and we've seen some of that just now in some of the panels I got to see. Community, other universities, foundations, industry companies. There are so many organizations that we need to partner with in order for the university to be effective at helping our society solve some of its hardest problems. And for all of those, I really see the Data Science Institute as being quite fundamental. So I hope you see that I'm very excited about this institute launching, and that from my vantage point, I see it as at the nexus of what it will mean for the coming years of the university, how it's going to be a place of great knowledge creation, of phenomenal education, and also a place of helping society to transform itself in positive ways. So thank you.
Thank you, President Alivisatos, for your remarks, for playing up causal inference. Now everybody wants to know more about causal inference. For your support, and as I said earlier, for your vision for a modern, engaged university that will allow the Institute to flourish. I also want to take this opportunity to thank all the panelists and all of you, all the participants in the room and on the live stream. I hope we made you even more curious. So come back and talk to us if you have questions to follow up sort of these days. But most of all, I want to thank everybody who was involved in organizing this event, from our hosts here at the Rubinstein Center, the Alumni Relations and Development staff, but most importantly, the Data Science Institute staff who did a lot of work, especially David and Minty, and Rob, who is somewhere in the back, and he took our emails last night, answered them on the spot, although it was Mother's Day.
And he also had to pay attention to every section because he was scrolling through the program here. Great, so just a couple final words. If you heard anything today that inspired you, or that you feel that you would really like to get involved with, consider this your invitation to do that. If you'd like to propose something new, if there's something we should be doing that you didn't hear us mention, please talk to us about that. And so please don't hesitate to contact us or any of these wonderful people here on the slide. And then finally, just I want to invite everybody to come upstairs to the 10th floor. There's a beautiful view. I think the sun is still out. But come on upstairs to the 10th floor. We're going to have a reception and talk more about data science. So thank you very much for attending.